guys ready?
Yep.
All right, let's go. Well, I guess we're gonna go right into roll call. Everybody's here. So, Giorgio, as Steve, do you want to say some opening remarks before we get Giorgio started, or should we just?
Yeah, sure. I would just a few, just anyway. I just want to focus everybody in on the agenda. There are two very specific agenda items tonight. One, obviously, is GIT doing their presentation of the alternative stormwater system. He's going to lay out what he recommends from a performance and a technical approach. And then secondly, and that's going to take a while, and it should take a while, so we should have a lot of questions. And then secondly, and we're hoping we can get to it, is then to go through, and Mike has this because we've been working it, and I think I sent it to you all on Friday, is a list of criteria that we will use that once GIT is done with their project, we can use that list of criteria to compare the AECOM project and the GIT project so we can make a very objective decision on the way we want to move forward. So with that, so we're going to provide a recommendation, but the ad hoc committee will make well, I'll leave it to Mike, but I would recommend that the ad hoc committee would make that final decision.
Based on the criteria you suggest.
Well, no, we're going to talk about it today.
Collective criteria.
Yeah, so that we can get your feedback, if those are the right criteria, if you want to change it, if you want to modify them, add, delete, however you want to do it. So I want to make sure you guys get a bite of the apple before we go forward with the exercise. So with that, Mike, you good, or we turn it over to?
I think we're ready to go. Giorgio.
Giorgio, let's go.
All right, thank you, Steve. Good afternoon, everybody. We're happy to present our conceptual. Can you hear me okay? Or?
Yeah, you're fine.
All right, should be close. Our conceptual stormwater master plan, which is an alternative, and so far we have done lots of different background studies related to the permitting, related to the water quality, related to many details that are important for the stormwater master plan. And in this presentation, we'll go over, first we'll provide a project status update. We're, I would say, like 75%, 80% completed with all the information. We have defined well locations based on field trip and based on lots of different aspects, like availability of space. And we have, after providing the injection wells, deciding where to place the injection wells, we've done analysis of how the injection wells impact the system. And based on the simulation with the models, we can see the injection wells draw water from additional areas from originally zone 1, which indicates expansion would be possible with the existing configuration. We are providing a list of network improvements, which are more classified as a rehabilitation of the existing system rather than building a new system. This includes also conveyance improvements to improve the distribution of the water without replacing larger portions of the largest portion of the system. However, we also recommend the inspection of the system. And the next task, we will only briefly mention about the next task, which are the next deliverable, which is the constructability and phasing, and also cost management. And the next slide,
Giorgio, before you get there, do you have any idea of how many additional residents you could cover if you assume you expanded?
So we are proposing, for example, and as you go further away, the effect of this drawdown from the injection wells, it's becoming smaller and smaller. But so we defined an area of 212 acres, which is double of what is right now. And
excuse me, double of what zone 1 is?
Zone 1 is 91 acres.
So you're saying now you're going to cover twice as much land?
Yeah. So this will cover twice as much, but this means that in the periphery of this expanded zone, the level of service may not be exactly. So it will be receding, but eventually, if you continue with this system and build another set of wells, they will be impacted. They will be working together. So that's a benefit.
But just to confirm and make sure that Ed and I are on the same page. What I heard you say was that with the same number of 6 proposed injection wells, we can cover double the area with a similar level of service?
With similar level of service for the majority of the area.
Okay. The majority being 80%?
I would say, so if we look at the numerical, our original estimate was 65 CFS would be needed for this level of service. And the reason we started doing this expansion is because we proposed 2 duplex pumps by 7.5, so we ended up having a 90 CFS capacity. So when you have a 90 CFS capacity, these pumps can work simultaneously at the peak time. And they will work only for, let's say, half an hour to an hour. So they are very short time during the peak event, the peak rainfall, the highest intensity. This pump will work simultaneously, and because they are 90 CFS, they will impact larger area.
So what you're basically saying is that the level of service is not static. I mean, no system can maintain the level of service the same way.
In all locations.
Yeah, as water trickles itself down to the bottom of it and the pumps start working, the pumps will work, I guess, not less, but will work with less. Yeah, I mean, lesser water, lesser head, they'll be activated less.
Further,
Yeah, further, and then you may have just a little bit of a, change in the original level of service, but it's dynamic. It's not like it's static. It's not like it's not going to work that way. It seems to me like it's just finding its way and being pumped down.
Yes, and you can illustrate this by the gradient.
But the gradient's going to make a massive difference.
That's going to be my next question.
The gradient, you can illustrate this at the pump location. The gradient is larger. You have a couple of feet of gradient, so you have immediately flow. As you go further away, this gradient is becoming flatter and flatter, so the effect that eventually, at some distance, it will be flowing in different direction.
And as your tidal effect comes up, you're also going to get a change of direction of fluid based on the previous.
So the tidal mostly will impact the groundwater because you don't have tidal on the surface.
But that's going to affect the groundwater, which is going to affect
yes.
the gradient of the water too as well.
Yes, it will affect also within the stormwater system, the tidal will be varying as well.
Okay. But that's not going to affect your laminar flow models to send the water different directions, because that's what you showed earlier.
No, it will not affect it. We have this into the model, incorporated into the model.
And he's got this in here.
Yeah.
Show it to you. What we'll do is, Mike, if you could get.
You know what? We're probably getting off track. So let's let him go. We'll let him run
I
through
was
this.
going to ask the chair, how do you want to handle, because I do have questions and questions keep on popping.
Yeah,
up.
and
No pop up. He's going to show. This is really the intro, but I do see we got 93.7 acres. This is 211.4. What we'll do, Mike, if you can, too, let's calculate the number of houses that means.
Oh, that's a massive improvement.
Yeah, it's huge.
I mean, in itself.
We have
is-
240
is,
houses.
You've covered a widespread area, but I think it's important that the residents are aware that, from the level of service, if they were expecting the water to be exactly at that level that we originally accounted for, is not going to happen, but it's going to be drawn down. It's eventually going to meander and find its way down to that pump station. But it's a significant improvement.
Yeah, so from the original, from the simulations, the way we have is the pumping effects are significant at the well, and then you but they also draw down much faster the peak.
Right.
So and we will provide the exact delineation of the location. This is at this point at the direction where the water flows towards the well, because we have 6 locations and you have drawing down the well.
All right. Why don't we just guys, because we're gonna stop them every 30 seconds, which is not appropriate for the people who wanna listen to the presentation. Georgia, why don't you go ahead and do your presentation?
Okay.
And let's try to hold our questions and write them down, and then we'll open it up to the end. Does that work for everybody? Yeah. Okay, great, thank you.
Yeah, so I'll go over the presentation, and so another aspect I wanted to mention, because we are doing this for the 2050 with no intermediate curve, which is approximately 1 foot above the current condition. And the model includes the tidal. So the tidal, in effect, the tidal complicates things, but it also, because at the high tide, you have more flooding, but this also within less than 4 hours, the tidal starts receding. So it helps actually the drainage. So it does both things within 12 hours. It increases the flooding, but it also releases the flooding. The project timeline, briefly to mention the project timeline, our ongoing tasks are currently the phasing and implementation strategy. This involves also constructability, how the phases can be managed, and we also started working on the cost management. The cost management, we have two approaches. First, we needed to have more detailed information about the items that are involved, different valves, different pipes, different the sizes, the dimensions. So right now we have already this information, and we are able to proceed with the costs. And we have two ways to approach. We can compare with the ACON, the original analysis from 2024. Probably it's good to compare that as well, but we also adjust for the current prices. So we will end up with two sets of numbers, which are going to be time sensitive. We have another ad hoc meeting on April 8th, when we will be done with the cost analysis, and then the final presentation will be on April 22. So we're currently in these two processes, phasing and budget analysis. One illustration which wanted to show you there are multiple elements in this stormwater master plan. There is a conveyance enhancements, collection improvements, where the catch basins and different inlets will be established. The inlets are typically connected directly to the stormwater system. Catch basin implies a sump, so it's a little bit bigger component. There are 6 injection wells with duplex and pump station. We located them, we moved them around, we went and did a field trip, so we have a good understanding. The outfalls upgrades, which is something that's optional, and we will discuss in what is the aspect of these outfalls upgrades. But they basically can be used for emergency. We do not suggest that they will be closed, but they will not be used. So there are four major program elements if we look at the proposed stormwater infrastructure improvement. And one is to improve the existing or rehabilitate the existing system. This will require conducting a CCTV to assess the pipe system, is there any need for repairs, and also to repair deficient pipes, which can be repaired either through replacement or slip lining. Both have advantages and disadvantages. Program element number 2 would be construction of injection wells. This we'll discuss more about what you already know, that they will be 24 inches of diameter, approximately 100 feet depth, and this can be phased or built in parallel. Because they're in different locations, but they're designed to work independently. In addition to the wells, a pump station will be needed to inject the water in the wells. Duplex pump, 7.5 CFS with total peak capacity of 90 CFS. The program element 3 is to upgrade some of the stormwater systems. There's a minor number of pipes that are 12 and 15 inches. Pretty much the standard is 18 inches. This will be upgraded. There is a significant number of missing branches, which results in dead ends. So these are indicated and located based on the survey. And this will require also, because this improves the conveyance, this will require also to add catch basins or to lower them so that they improve the inflow. In addition, program element number 4 is to repair the outfalls. This is not in any way urgent right now, or it's planned. This is optional, and the purpose of this is to provide another resiliency type of redundancy to allow emergency outflows or extreme events. So going to the next.
Georgie, if I could real quickly, you say to your left, road resurfacing, what program element would you put that in, 3?
Yes, that would be.
That would fit,
because that will
catch
improve in catch basins and improvement of conveyance. Yeah, thank you, Steve. Like we missed that. So also wanted to mention that this has water quality. We have also looked at the water quality. Using this stormwater system allows you to improve water quality in 2 ways. One is typical, traditional, using hydraulic separation. This is like a cyclone type of that rotates and separates and removes, based on the manufacturer, approximately 80% of the annual sediment load. This is mostly mineral composition. Some minor organics is removed. Injection also support additional subsurface attenuation of the pollutants. First of all, groundwater moves extremely slow, so if you inject anything in the ground, it takes tens and hundreds of days to move to the bay, so it's not instantaneous movement as discharge. During this movement in the ground, water is in anoxic conditions, which causes some maybe minor, but still causes some denitrification and some phosphorus reduction and foul precipitation. So yeah, we know these are minor. This also depends on the aquifer conditions. It also total suspended solids are removed, and again, this is not resulting in any permitting improvement, but this is environmental fact that that injection in the ground is positive for the environment. So going back to the where are the wells? The original zone, which is the blue highlighted zone, it has this irregular shape. We located the wells within this zone. So there are 6 wells. We looked at available space and also the efficiency of how water can be pumped in the ground. After the installation of the wells, the hydraulics of the area changes because the wells create a sink, basically hydraulic sink in the area, and then you start drawing water from outside of this zone 1, which kind of caused the redefinition of this zone. Basically, we changed the watershed to have to reflect this aspect, which is the pink color. It's not very strong color, but it's the pink color. So these zones will also benefit from these wells. These areas that are pink color will benefit from these wells. They may not get exactly the same level of service, so it will be, but there's going to be a significant mitigation. So we wanted to reflect that. So that's nearly, that's exactly 2.1 times. The revised boundary, which actually it's more representative for the modeling purposes, and it is preferred for capacity evaluation and for flood assessment because it impacts these areas. Now, there is further impact to the north, but this is much more attenuated, and it was not significant to add. So for these areas that are outside, another set of injection wells would be recommended. Here is the groundwater, here's what a groundwater well is, how is represented. You basically have the ground surface. We had this discussion in the past. You're injecting directly in the well, and the well has screens, and the water moves laterally. As it moves laterally, it has a resistance and creates it has effect which is known as mounding, groundwater mounding. And the groundwater mounding is one of the parameters for permitting. Like FDEP does not allow greater mounding than 6.5 for coastal areas. So that's under certain conditions. For example, if we show groundwater model and we show that there is no public water supply, and we demonstrate that there is no flooding resulted, they can allow even more, but based on the discussion, they said that this is very rare. We have the groundwater model that's produced this data. So that was the next verification we've done, like after we moved the wells and we started injecting 90 CFS, we checked the groundwater mounding. That will allow the permit to occur, and we will be preparing preliminary, the FDEP call it pre-application, which includes the groundwater analysis, and along with all this information for pre-application for this permit. We clarified where the existing lines. We reviewed both the stormwater atlas and also the KCI information. So the missing lines, the proposed 24, the existing lines are with red, and the proposed are with type of orange color. And you can see that there is quite a bit of dead end. We already discussed this, and these could be added. This will improve the overall distributed network effects, and this will improve the entire flow of water. This is important for the wells because they need to receive from all available sources. Then we have analyzed where would be the best location for the surface structures, and surface structures are really the catch basins and the inlets. The inlet is directly the roadway drainage, goes to the inlet and goes to stormwater. The catch basin typically trap sediments and have a sump to settle, so that's typically used when you have grassy areas and so on. So we are proposing a number of catch basins to be placed, and these are based on the flood map. Once we developed the flood map, we looked at every single location that looked flooded, and for example, just to show you, maybe it's very difficult to see, but so for example, this dark red is within the parcel. And that also illustrates the question that for this analysis, we use the entire area. So we don't have just 100 feet of the road, but we use the entire area. So the entire runoff, so this in between the parcels, you have accumulation of water. Then we looked at the road, and so we don't do anything within the parcels. But where the road is, we can see that there is area with that's flooded. The road is flooded. So, and then there is no catch basin there. There is no nothing for the inflow. So we place all these blue squares are locations which can be eventually we can put catch basins or inlets. That will improve the inflow and the drainage of the system. Again, this is located based on the flood map. So and there are, in some cases, we have existing catch basins which don't have the I guess either the rim elevation is too high, so they don't have much effect. And we can see at each point what is the inflow in CFS, and some catch basins have inflow up to 5 CFS, some catch basins have 0 inflow during the flood event.
Giorgio, before you jump, I know in the last presentation, I don't remember the exact number, but it was something like 215 that you had to look at and possibly modify all existing ones. Are these new locations? And then you would still need to modify the existing ones, or are these the ones?
Are new locations.
New locations.
These are new locations in the extended, totally extended
the
zone.
extended, okay, but we
Yeah.
still have the ones in the blue zone, so to speak, that
Yes.
might need to be modified.
Yes. Actually, the blue zone also has a new catch
A few
basin.
as well.
Yeah. So these the blue squares here represent the blue.
That's all the blue ones, okay.
Yeah. These are the proposed catch basin. The existing ones are shown with yellow points. So we have one aspect that we're recommending for resiliency, which we call it optional, but for emergencies and for emergency conditions, for some reason, pump failure or some conditions or some dramatic happens to the network, we're proposing force mains, which the pump can be switched to pump water in the outfalls. Again, this is something that's not. I would not call it a part of the system, but it's optional, and I would say this falls under resiliency, and also under long-term resiliency that will address whether maybe it will be higher sea level conditions or much larger events. For example, you can address 25 years or a strong hurricane with much deeper flooding. They will help the system to be drained faster with the same pump. We revised the layouts. We probably will do additional revision, but one of these wells will contain the hydraulic structure, the hydrodynamic separator, inflow from the stormwater system, hydrodynamic separator, then it flows to the wet well. The wet well will be deeper, approximately 15 to, we have to finalize the exact dimension, down to 20 feet possibly. The purpose of this is to provide enough volume to allow pumps to switch less or to be more efficient. And then we have 2 pumps that are submersible, and then we have set of valves, shut-off valves, butterfly valves, to be able to separate these. So these 2 pumps merge in one single manifold, in one single pipe. And we are branching out one of these that can be plugged and stay in the valve box. This is a valve box that will contain all of these appurtenances. So this is not a small box. It's approximately 37 feet. The well structure, the hydrodynamic structure is 8 feet for this flow rate. And then from here, we will have flow to the pressurized well, and it will be pumped down. This is a smaller structure. It's like 8 by 8. All of this is underground, so there is nothing above the ground. The only thing above the ground is the electric panel, which will be placed above the base flood elevation, plus some freeboard. So this is also illustrated, the profile of this system illustrated here. So the benefits of this is that it's all below the ground. And you can see you have examples here. The only thing, except that you have the backup power in the other locations.
Can I ask you, I'm sorry,
No, it's-
I do have a pertinent
Giorgio,
question.
are you ready to start taking a couple questions now, or how?
If you prefer to ask questions, yes.
Are you prepared to, can we take a short break and ask some questions now, or would you
Yeah.
prefer to continue?
Yeah, yes, let's discuss.
Thank you, Mr. Chair.
Network is probably a good
I
I got a couple of
I think
questions
it's a
for you.
time to.
Yeah.
Yeah, I have a couple
questions.
questions, yeah.
Go
Just-
ahead, Fred.
I'll give two questions, so just to kind of, yeah. The first question I have is that I like the manifolded system. We recognize in the past these pipes are dead-ended, as you said, right? They have to be connected. And I'm wondering if in the process of you have a very interesting design in the sense that it's novel, I guess, novel from the standpoint of being new from applications. And I think that there is an opportunity here to perhaps think it further with the wells and the manifolded system. Is there a way that you can help by recirculating the flow, help reduce the peak? In other words, how much storage would you have in those current pipes and those existing pipes or increasing them? And if you could, I'm thinking about the force main approach. I think that's a great idea, but it still speaks of potential capacity and not meeting the requirements, having to discharge into the bay. That's the part I don't like too much. I'm wondering if we can minimize that by recirculating the flow within the existing pipe system now that you're going to be connecting it and manifolding it.
So the discharge of the bay are not considered. This is only for emergency.
I understand.
Or only. So currently the way system is designed, everything is going to be injected in the ground.
I understand that too.
And other than that, we talked about possibility. We had a discussion about if it's possible to control the system, but we believe for this size of application, that will be very difficult to implement some automatic controls to distribute, redistribute. So they basically will be hydraulically connected, and
Well, you have an enclosed system,
yes.
so all that you would be doing would be recirculating the flow through gravity
And injecting into the ground.
and injecting it into
Yeah.
the ground, allowing yourself one round before going in. It's a way of reducing the peak. Think about it.
Yeah, we
I'm
could.
not sure how you could input that in a model, but if you say you discharge out of let's say 300 CFS, just to say, or 200
Yeah.
100 CFS, you've discharged at 60% at peak, right? And all of a sudden you're left with a 40% roaming around. Can you keep that in the system and use the system for storage, for peak reduction, and eventually going back into the well? It's a way of preventing the flow from going into the bay through force mains. Just a thought.
Well, that's something that we need to review, but I think in the overall opinion is to have everything to be very simple in a way that would not have inherent complexities that.
Okay. The other question I have is, do you intend by increasing the area to reduce, because the ACOM design, I think, proposed some roadway increase in elevations to protect some driveways. Do you think that you would not really need that, or would that be needed? Because those could create natural barriers. And if you want to capture 211 acres, you want to look at your barriers, right? And are those some of that ACOM, may have inadvertently designed?
Yeah, so they showed the increase of the roads, elevation increase. What we refer to is really resurfacing of the road and redirecting the flow to the inlets. So if necessary, in some locations we can resurface the road, but global increase of street, for example, street to be increased, like we're not considering that. And one of the reasons is because when you have in well, and if the water is pumped in the ground, you already have a gradient. As soon as the water enters the inlet, it will be drawn down to the. So the road, whether it's higher or lower, is not as significant as the ability to receive the water.
Right. So my question, maybe I didn't say my question right. Do you think that it will be different? The ACOM design suggested raising the road in some areas. I guess the straight question would be, does your design have that as well?
Yes, but we call it a little bit different. We're not calling it increase the road, but calling it resurfacing. Yeah, that will require some resurfacing. it will increase in some location to allow the proper, and maybe the lowering in some location which is higher. For example, there are some catch basins that they're like surrounded with a little mound, so that would prevent the efficient inflow. So it's more of having some expert to go around the catch basin and make sure that they have like a clear line of sight with the slope, and this is not mountains
I mean,
like
however the water gets there, I have an issue,
Yeah.
but there was some expectation, I don't know, in some areas that some of these roads
to elevate.
were going to be elevated.
Especially around the school.
Yeah, so my question, if it's not, and your design is very different, it's not the same design, and that's
Yeah,
what
yeah.
people need to know. You're talking apples and that's oranges, so we can't compare it, but raising the roads, it's an important, it's aside from the drainage system. It has to do with ensuring that, elevations they don't flood naturally, and the water finds itself faster to the drainage system.
We have analyzed the surfaces based on the LiDAR data and based on the ACI. There are some roads that are really low.
Yeah.
They're like 1.2, 1.3 NAVD, so they're really low. These could be possibly considered, but at this point, we're looking more at redirecting the flows rather than raising the road. And this raising will naturally occur at locations which are low and collecting water. And in some of these locations, we're placing catch basins. I think we need to kind of go in specific examples and discuss this for a specific example, because for the entire area there is a variety of configurations. Some of these needs to be fixed. Some of these.
You're going to tweak the grades a little bit to make sure that the water finds itself to a certain point. And
Yeah.
in tweaking the grades, you're going to make sure that there's no issues with, harmonizing those driveways, areas that you're going to elevate. It's pretty intricate design.
Yeah,
But-
that will require very accurate grading.
Okay. So there'll be areas that'll be elevated, others won't be. Okay.
Yeah, yes, but based on the LiDAR data and based on this would be, like, I would say, like, minor, not more than like, just to put a number, 1 foot. Because in general it's very flat, but you can see in the roads it has like sags and that were collected. So these would be raised locations.
Would you say, Giorgio, that the increase in the number of catch basins would also help in that design to deal with the harmonization that Councilmember is talking about? 'Cause
Yeah.
You're adding additional ones, and I think
Yeah, adding catch
you want to make
basins.
sure we're not throwing water in people's front yards.
Good idea.
Yeah, I mean, it's a very delicate, we're not designing the space shuttle here. We're not going to build a space shuttle either. It's civil engineering. It's as accurate as the field allows you to. So, some things are well thought, but they're not necessarily well constructed. And we just have to be cautious of that.
Yeah.
I'm not suggesting that your design will be good, somebody else is not good. It's just saying that when you get out there in the backhoes and the contractors start laying out pavement, concrete, whatever, it doesn't work that well. So we just have to be very cautious when we go into changing elevations.
Yeah, it has to be accurate. It cannot
Yes, and the former design, just saying, had, like all other, designs have, is just, they look at a grade.
be. Yeah, completely agree
Straight
with
out.
this. That's critical. You can design it, but if you cannot construct it correctly,
Right.
so.
Giorgio, you showed this, we're gonna double the 211 acres versus 93 acres. You're gonna have to add another 190 some catch basins, God knows how many lineal feet of new pipe. We basically put a committee here to say, is there an alternate way of doing the ACOM plan for less money, significantly less money? Is it possible that you can give us 2 prices when you're doing your cost calculations, just to cover the 93 acres, so we can compare apples to apples, and then you can give the 211 acres, and we can see how much the incremental cost would be, and how many houses we would get by doing that. Is that possible for you to do?
Yes, we're actually doing that.
Good.
We
You're ahead of me.
will
It's good.
Yeah.
You're asking the exact same question I was going to ask.
All right.
We
Mike
will-
wants to ask that question.
No, I'm just saying, you answered exactly the same question. Yes, we were tasked to focus on zone one. And
Right.
the fact that we can cover
Exactly.
more homes
You're like doing
is,
both.
is great, but we just want to make sure that we have apples to apples when it comes to financial information.
Then-
Yeah, yeah.
Well,
It's-
then, Giorgio, I asked you before, and I'll ask you again and again and again. What is the probability of having these events where we actually turn the pumps on? And what's the probability of electric going out at the same time as having these things? And the reason I'm saying that, because I don't think you're a salesman for the generator company, but I saw you proposed 2 generators in the last thing you told us. And when everything I talk to you and everything, I look at the numbers, obviously statistically, probability-wise, generators make very little sense. And it sure is always good to have something, but it's good to have, a policeman for each individual, so you don't have any crime, but we don't do that. Same reason, we're not gonna have a generator if you're gonna use it possibly once a year, once in 5 years. So my question is, how did you come up with those 2 things after we talked about the probability of having those things happen? Why did you add generators?
So to answer this question, we're currently in the process of analyzing the data. We're even though and in general we want to see the following. First, we're doing design. The design for the rainfall is once in 5 years. Our criteria is 5 years design, return frequency. For the generators, we are scheduling a meeting with FPNL because we want to understand the data that will have power outages. So that's one of the aspects. If you have the undergrounding, that dramatically reduces the outages.
Stop. We're talking about not the current system of aerial lines, we're talking about assume underground feeders. What is the probability of underground feeders going out? And how does rain affect underground feeders? And then take that probability, forget 5 years, look at 10 years. Look at the 10-year events, not on this one, but in the prior handout you showed, I think you said more than 4 inches per hour was the cutoff. How many times did it happen in 10 years? Almost nothing. Then take the probability of having the electric going out at the same time. Again, take them together. How many hours out of 10,000,
Yeah.
out of 70,000 hours did it really happen? And how much we're going to spend just to do that, besides maintaining it on a weekly basis? I mean, you repair the generator before you even use the damn thing by turning it on and off every week.
Oh yeah, well, we're familiar with all the issues with the generators, and so we did not really say that configuration is you need 2 generators. We only said that there is realistically there is a space for 2 generators. There is a space.
It's a space for a lot of things, but the question is,
So
why are you going to have it?
And if you have
maybe we, instead of going down the road hard on the generators, which I appreciate your concern, Ed, is the possibility of maybe having connection to have a standby generator if necessary, for example.
On a trailer
On a
mount.
trailer basis. So
Well,
we have
all of them will have
I
that.
think,
Yeah,
but I think,
all of them will have
I think the intention would be, in the event that we have some mechanical, God knows electrical failure, but if we have a standby generator that can be brought over, connected, it makes reasonable sense. And I think we're gonna probably get forced into something like this. But most likely they won't, but we're probably gonna be forced into that same situation.
We're talking about something that's never gonna happen.
I don't
Never
think-
say never. Yeah.
so
That's what never happens.
so just to clarify,
We're also talking about something that is really easy to take out of
Exactly.
design.
If
So,
you can take this
I
out,
mean, so,
put it back in.
so
but,
much
but,
better.
but no, what I'm saying is, we don't have to make that decision right now, we make the decision when it's
It's a
needed.
decision.
It's
I'm just
really
saying I
easy.
saw him
Yeah.
Put it in there.
No, I know, he's got stuff right here, but what I'm saying, it's something that if we go down the road, we don't like the cost of it, we wanna make that move, we just say, Giorgio, design it with how
Yeah, okay.
Generate, I mean, it's so,
I got you.
we don't have to debate it right now, it's,
All right, fine.
that's an
Just wanna know
easy
why.
decision when the time is.
Mr. McCormick, he's had his hand up. He's gonna lose his hand.
I got
So,
it.
just hearing the people that are.
Candidate McCormick, I should say.
That you were right about everything you said until that part right there.
What's the McCormick part?
He's not.
Tom McCormick, 680 Curtiswood. So I've been trying to follow these raging debates for the last couple of years, and it was first we need to do something about stormwater, and then it was about, oh, the existing system is great, it's just not maintained. It is maintained, it's not maintained. Then it's, do we have to televise and slip fix everything? And then it was, do we pump to the bay? And if we pump to the bay, what does the county say? And do we have to ruin Harbor Park with filtration pumps or not? And so I've been following what people are arguing about. And now the argument, it's a good argument, is, well, wait on AECOM for a minute. Is there a Giorgio idea that could maybe get us the same place or better for less money? So that's what I've thought all along, and I've loved the work you've been doing to figure out that hard question. And I'm late to this, so forgive me if this is an absurd question, but I just noticed for the first time that we're going to put 190 new catch basins in the expanded Zone 1. So if I do a half-assed projection village-wide, that's 400 or 500 new catch basins. So now I'm saying to myself, is the principal driver of the lift we're going to get from Giorgio's plan, because we're going to put in 400 new catch basins village-wide? And if that's true, should we maybe not be worried about what to do with the water once it's in the system? Should we be saying the problem is the water never gets into the system? In other words, am I the only one who's just now realizing there's going to be 189 new catch basins in Giorgio's design? You've all understood that all along, that we were going to have 189 new catch basins?
In the expanded system.
20 minutes.
Okay, so 150 in the, whatever the hell, Zone 1, Zone 1.5, whatever it is. In other words, how much of the benefit is because we're deep water injecting this, and how much of the benefit is, no, we're just letting the water get into the city. I live on Curtiswood. There's 8 new catch basins on that one little short block there. Is that most of the lift on this
They're
project?
taking the water to the injection wells.
Right. But right now, that water is not getting into our current system. It won't get into the new ACON system, and it won't get into the new Giorgio system unless we build these new catch basins. That means they're not out there now. My question is, if you had the existing system left as is, patched where we know it's broken, televised, not televised, but would simply building these catch basins markedly improve our stormwater drainage, or am I misunderstanding the engineering so
The
fundamentally?
engineers usually say
Yes,
that
but no.
basically this system with the wells we have and the head, the differential between the top of the catch basin and where the what you call the water level is, can absorb so much water per minute, per second, per hour. They also say to get a rain intensity of 4 inches, 5 inches, whatever the numbers are, it can't absorb all that. And as a result, you have flooding. Doesn't matter how many catch basins you're going to have. The water has to go somewhere. If the actual existing wells can only take so much water by gravity, then you need pumps. And if you don't pumps, you can do what AECOM says, get it all to a central place and pump it into the bay.
Got it. So what you're saying is if I snuck out tonight and myself built these 189 catch basins, it wouldn't do any good.
Water doesn't have any place to go.
That's what I'm trying. And guys, I'm dumb, but you need to be speaking to dummies like me, because we're the ones.
You're no dummy.
Right. So but my point is, so whether we go with Plan ACOM or Plan Giorgio, that system is going to have greater capacity.
Yes.
And either way, we're going to be building tons of new catch basins to get the water more quickly into that new system. So right now, the limitation on the current system is not because we didn't remove the leaves, which we screamed and yelled about for years. It's not because they're cracked. It's not because of the county ordinance. The problem is even if we had a catch basin every other foot, it still can't move that
Bathtub's
much
got
water.
the bathtub doesn't have enough capacity.
Well, the water's gotta go somewhere.
It just, as a layperson, it seems to me that a village which is tragically short on catch basins, of course, has a huge stormwater problem. But what you're saying to me is, no, that's not at all the problem. The problem is what's underneath the ground. The catch basins, doesn't matter if we had the catch basins, it's still
Well, Tom, I
won't
think
work.
it's inherent to the system. If you can't get into the pipes, it's not gonna go anywhere. But if it's in the pipes, you gotta have some place for it to go, right?
So-
And so whether it's in the ground or whether it's out, it's that.
So since none of the water is getting into the system because we don't have nearly enough catch basins, we're still strongly convinced that if the water did get in the system, it still wouldn't go anywhere because the bathtub's not big enough. We're still strongly convinced of that.
Yes.
Because again, it's ironic that we're talking about what a crappy system. I wish it were good. No, it wouldn't matter if it's good because there's no catch basins anyway. So ACOM plans on lots of catch basins and you plan on lots of catch basins. But doing catch basins now would do no good whatsoever. Okay, everyone's nodding, so I'm super confident in that. Thank you for clarifying. Am I allowed to give the thing to Lucho or would you rather I did?
Why not?
Yeah, you know, if we were to not put any catch basins and just do some injection wells, that would improve the system significantly.
For sure.
So it's the injection wells that actually do the improvement. Not, you know, the catch basins, what they do is make sure that you're picking up the water from everywhere. You know, you're putting injection wells, might as well put the catch basins to get rid of it. But the catch basins, you know what a catch basin is, right? It's like an aquarium without a floor. It's got rock at the bottom.
I know my block is constantly flooded. You know what drains it now? A week of evaporation. You want to know why? Because there's no catch basins.
Correct.
Right.
There's two.
Right.
There's one at the
But
corner.
the catch
and one
basins
at the
need to
front.
go somewhere. It just can't be a catch basin. It's got to be a catch basin and a well, or a catch basin and an outfall.
And a pipe to get to the
And a
well.
pipe. We have some that don't have pipes.
Okay, yeah.
But, okay, well, that's a very good
real quick.
question, but I was just going to also add that all of these components add together to the efficiency. I think we have further in the slide, we are estimating based on simulations that injection wells alone will bring 60%. Like we just scale it to a percentage. Injection wells alone will bring 60%. Then adding these missing lines would add another 10-15%, and adding the catch basin with the appropriate elevations. So they all work together as a single system.
Giorgio, can I ask a quick question, please? So if we decided to phase the installation, for example, and we wanted to do 3 of these injection wells, we just pick the strategic hottest spots of area that we have to address, will the system still network under the current design, or do we have to modify that design?
Yes, the system will network under the current design, which will not be as efficient as if you built all of these components. But I think it's a good strategy even, and I think you're actually asking questions that I have further in the presentation, but I put a.
If you want to start at the phasing conversation, I'm fine. Just carry
So,
on.
just to give you a phasing conversation, because we're currently looking into the phasing, we'll have a recommendation, but for phasing, we think phase number 1 is to construct the distributed injection wells first, just because, and we'll lower down at the bottom, we place that we're estimating that 50 to 70, average 60%, they will improve the mitigation by 60%. If the total system is 100%, you'll get improvement 60%, and it will happen right away. So this is an early win, like to get injection wells and start injecting in the ground, and you can continue with the adding the network. This will only improve the system. You can continue adding the catch basin. This will only improve the system. So that would be the phase 1.
But
Giorgio.
what I wanted to make sure I clarified, Giorgio, was that assume, just for purposes of conversation, that we did 3 injection wells, just 3. Would that system function, those injection wells function standalone without the necessity to have the rest of the system built at this particular time? And will it meet the level of service that we have recommended?
So for the level,
In those particular areas?
so for the level of service, I think where you have connections and pipes and the appropriate, it will meet the level of service. For example, to give you an example with this UC2, maybe I should point. Let me point to the other screen. So let's see. This is this well. You have a lot of not connected pipe. If you place this well here, you'll improve this entire area, but this will not do anything here. So that's the, and then around the school, if you place this school, you basically will not have much impact in these areas. Mostly
Because there's no lines.
there is no line. So
But you can't do without the lines. You'd have to put the lines in. Yeah.
so yeah, so it will cause improvement in these locations. So it will be limited.
I guess the simple question, I think, and I'm going to try to translate, Mike, what you're asking for, is you're suggesting 6 different wells, ideally working as a complete network system where it gets its greatest capacity. If we were to choose, I don't know, let's pick 2. One, in the southwest corner of the school, and the other one in Harbor Park. Would those be effective? And the associated pipes, obviously, we're not going to put it there without the pipes. Would those meet the level of service that we've given you? And I think that's the question you're asking.
For those areas.
For those areas, of course.
Yes, for these areas, yes. So for these areas, for example, if you put this in the harbor school, this entire area would be very much mitigated.
And you'd be able to identify the coverage area, how far that goes out to give what level of service it provides.
Yes.
And then a second question for you is that you talked about the northern, I'm going to call it the northern boundary on the page. Is the reason why we're not getting able to extend farther north with the current system? Is that because the gradient changes?
This one, it's just the way the streets are placed, and there is also missing pipes here. That's already going to completely different like zone, really.
Because the gradient?
The gradient is pretty much flat, but it just there is missing pipe, and there is small diameter, so
So it's
that will require to
more mediation.
What we the way we looked at this is these are missing pipes, so they can be reconnected. These are missing pipes that get reconnected. But then when we looked at these, there are some missing locations, some dead ends here. So
So it doesn't fit the criteria. Okay. And then one last question: when you go back to the pit drawing where you have the hardware pit, right there, back. Okay. That valve that's going out of the box in the north corner, that's the force main. So you're basically going to take the same pump and put a manifold there, and then you could send the water to the outflow if you chose, or use the water. Okay, that's what I figured it was. Okay.
so this would be
So
plugged.
it's the same pump. We're not reversing directions. We're just running the pump in a different direction.
Right.
Got it. Okay.
So
That's what I figured.
technically, what you could do here is build a valve box,
Yep.
build all these, add all these items, and here plug it, and don't even show it for a later stage.
Okay, I just want to make sure I understood the
That
design.
would be the idea.
Okay.
Let me ask you a question on this one, on the phasing. What would your opinion be, so we're gonna start, let's say, with 20% of the entire design. I'm just throwing a number out there, it may not be, maybe a little more or less. And then we have the rest that needs to be constructed. In order to achieve a full system, what would you recommend the village to do? Do it within a period of 5 years, 4 years? Because by a certain time, we're gonna have different climatology, different criteria. I don't wanna create something that later on we have 2 great pumps, but it's not really part of the whole design.
Yeah.
So if we're going with a Lego approach, I have no problem, as long as we know we're gonna finish the toy.
Yeah, that's a very good question because I think the active components of this system, you can consider the injection wells the active components. These are the things they will mitigate the flood. The rest are bringing the water there
I
for
get
the
it,
service.
but strictly engineering speaking, engineering and programmatically speaking, and if you don't have an answer today, you don't have to provide it. But I think we need to eventually know, because we're telling the residents, we're going to substitute. It's a fine design, but it has to get done. It has to be completed in order to achieve the level of service that we promise the residents. So I like to know how long that's going to take.
So I think so. What I think we're looking at, and I'd like to ask Giorgio this. I'm looking at this. This seems like a construction phase versus the ability to do it in phases. Because I'm looking at this and I'm looking through it. This is what you're suggesting and how we would do the whole thing.
Yes.
Versus what I think I hear Councilman Bracken saying is, love to do the whole thing, but if we want to do part by part, how would you do that?
How would we want to do that?
That's like building a pipe and then
I
building the
was
system.
thinking, I was looking at the fact that maybe at the end of the next year, that we ran out of cash because they took all our money away because the government decided that they were gonna do ad valorem taxing anymore, and I wanted to be able to look at a cost flow analysis and be able to say, okay, we built part of this and we do part of the undergrounding.
But isn't this
We
still
have-
part of an enterprise zone thing? Nothing to do with that, taxes?
It could be.
Yeah.
Yes.
So it doesn't matter.
But yes, but no. Like we'd have to go back and
Yes, but no.
get a loan to cover it. So
Just looking at the cash flow, just wanna see if.
yes, but I also wouldn't just want to rely only on that enterprise because that would have a high burden on certain people. But we would come up with a funding strategy. Yes.
I'd like to know, and I think it's an important question to ask, how long will this system get to build to achieve what we need to achieve? Or are we just throwing 2 pump stations and then calling it a day? You can build a building in pieces, but you're not gonna leave 2 columns out there and then come back 20 years from now and then do it when we have money. I think that is a sincere red flag in my opinion. We need to do it now completely, or we need to have a phased program, a committed funding stream that's gonna get it done.
I
And
think
that's what
that's
I'd
the
like
correct
to ask
answer
you. I'm not
because-
asking to do it,
Yeah.
I'm asking you, how long do you think
The
it's gonna take?
I think you answered this question because I think lots of this is hypothetical until you know the funding mechanism and until you have the funds. Because I think what we are doing right now is you can build this, you can build this. But to give you a schedule, we actually, once we look at the costs, we can provide the costs and then we can provide some guidance regarding this. At this point, we're like schedule is, you can build all of this at the same time.
Yeah, but Steve went ahead and figured out how we could fund the $78 million or whatever it's gonna be for the ACOM. And we know yours, we better know yours, you help us say cheaper. So we can fund that, I'm sure we can fund this thing. And it's gonna cost a lot more money if you do a piecemeal, you drag it out over a bunch of years. Costs go up, aggravation goes up, et cetera. So I don't know, make any sense at all to phase it, other than, like you say, phase the construction, put your pumps in first, et cetera. But I would do the whole exact zone, not mess around with part of it.
Question.
I'm only one person.
Let me switch. On the valve box, that's, you said that's 37 feet?
Yeah,
And all 37 feet are underground?
everything is underground. Only the electric panel.
Yeah,
To the left.
Yeah.
The only thing that's
This
above
guy.
ground is that electrical panel.
Do we know
Only
where
the
that would
electric.
be?
Sorry.
Do we know where that would be?
Where those blue dots are? The big blue
No.
dots on his network?
Where this would be?
Yeah,
Yeah.
those blue
Well,
dots
which
are.
blue dots?
Go back to
Go back
show
to
where
this
they would be.
Schematic drawing.
Okay.
Do you have a picture? Send
It goes
it to Joe so we can.
right there.
What it looks like, it's all underground.
Yeah, we
I couldn't find my
have more detailed plans. Like for example, this would be the location of one West End Drive. This is at the school. That's how it will be in scale. So they're very long, but they're underground and they can fit between the right of way and possibly in some cases will be under the road when the right of way is very. But this would be the blue line is the right of way. There is the utilities are printed. Yeah, there.
Is the water coming into this box?
Yes, it would come from this point and it will move through here and it will be injected in this point.
So the water comes into the red thing.
So it's all sitting
It's all below grade.
on a concrete slab under the earth, and
Yes.
it will go through there to your different distribution points.
So the idea is it comes into the red box, that's basically a device that sends the water in a round circle, drops the particulate to the bottom, that flows into the main body, which is that's that part here, Joe, which is like the sump pump. It's like the bigger, it creates the capacity, and then it pumps through there, and it goes to the well, and it goes straight into the ground. That makes
Drainage,
sense?
this is the
Yeah.
drainage.
And that's all underground.
Yeah, this is stormwater, this is the water.
That pumps underground as well.
Except for the electrical panel, and if we decided to do the generator over there also.
And there's a lot, I mean, Fernando can probably has seen pictures, there's several of these in Miami Beach where these whole devices are on the ground. It's not an uncommon design.
I have another question. Have we been, can you include it, or are you considering in your report to provide, the pump stations, et cetera, are you providing an O&M costs for this system? Because I think that eventually, that will, eventually there's a life cycle maintenance component on this that I think needs to be taken into account. This is a
Part of, yeah, this will be a part of
complex
the
asset to maintain.
Yeah, it's part of the cost estimate.
That's part of the cost estimate.
As part of the what?
That's part of the cost estimate.
It's the life cycle cost.
Okay.
Do we have the same for the other program?
Yes.
Okay, do
To
you
make sure we're
anticipate,
comparing apples and apples?
yeah, do you anticipate it to be more or less?
for smaller system.
O&M costs, it's post-construction.
I mean, it's obviously more systems, so there's gonna be a little bit more on that aspect. He doesn't have all the infiltration baskets,
Right.
so that's a high percentage of the cost on the other one, so we haven't seen it yet, but
Okay, Steve, quick question for my edification. O&M costs, will they come, they're also paid by the bond? If we need to do.
No, O&M costs,
That would be general funds,
that'd be general fund, it'd be current year general fund.
so that would be attributed to our.
That we have to be in the budget,
foreseeable-
which we could use our stormwater fund for.
We could use. Okay.
You guys done?
But also realizing that well, it's not going to
Yeah,
financing right now.
Yeah, with all the stuff that's out there, but I just want at least to know where the.
Yeah, no, we can't bond that, no.
One last question, Giorgio, if outside of additional catch basins and additional piping to do the expansion, there's no other equipment required because we're using the same amount of pumps, the same amount of the same amount of hardware, we're just adding more pipe and more catch basins to get that greater expansion, correct?
And manholes
And yeah.
joints and
Yeah,
all
but
these.
just, so,
Yeah.
so the vast majority of the cost is the wells and the pumping equipment, so we're just amortizing more, we're taking more pipes and more catch basins over a greater volume of homes, correct?
Yes, that's correct. That-
I mean, that's a significantly interesting thing.
So I think just as a parallel, both plants have the same components. They would have the pipes, they would have catch basins. I think one of the differences here, we're talking about rehabilitation of the existing pipes, so we're not proposing these to be rebuilt, completely to be built. So that's.
Unless they need to be.
And Christie, for purposes of conversation, do we have a price roughly for scoping the pipes yet?
Yes,
Okay.
I received 2 unofficial bids,
Just,
two official prices for televising all the lines, and it was
In zone one, right?
for Zone 1 only, and it was approximately $450,000.
How many,
cheaper
how
than
many
having
lineal
to
feet?
replace all the pipes.
Chris, how many lineal feet of pipe is that?
It's broken down by the size of the pipe that's out there. Approximately 20,000 linear feet, I believe, was
20,000 feet?
approximately. Yeah.
It's like $20 a foot.
Going back up to the revised Zone 1, what was your criteria to, did you move these, you moved some of them significantly, right?
The boundaries?
That's the scope of.
Yes. So the criteria was, the first criteria, we looked at, all of this is
Go
existing.
to 2.2.
Flushes and checks the water flow with the scope.
There, yeah.
Okay, so
Is this different, how much different from the prior,
this one's, the blue versus the pink.
There's no pressure storms.
the blue versus the pink? Okay.
So the pink is the larger.
So I think the question is, do we have to relocate the,
Can.
the injection wells to cover the, or the injection wells staying in the same place?
We did, the process was, we started with Zone 1.
Right.
And we placed the injection wells in certain location. We realized that we need approximately 6 to provide the coverage. So then we started moving them, and so this condition, once we move them to this condition, we decide, okay, so that will extend. And the following, I guess, optimization is do we want to try to move this one towards here because it will serve, it will provide, so that would be some kind of optimization. So we haven't done that.
So, yes, you moved them a little bit, or you haven't
We
yet?
moved them a little bit, but after we moved them, then we expanded the zone and we keep them as they are.
Fundamentally, we have 6, we still have 6.
Yeah.
Yeah.
If I may, Georgia, one more question I had related to the permitting. There's, how many, are we looking at different components of permitting here? Can you walk us through
Through the permit.
through the permitting? Thank you.
Yes, so there's 2 permitting agencies we need to deal with. One is Miami-Dade County. And Miami-Dade County, we had a meeting with them. Their preference, of course, is injection wells because they don't want to have any discharges. They have very difficult times with a lot of, there is 9,000 outfalls, Miami-Dade County
I
from.
agree 100%.
So they don't want to have, so
No
for
brainer.
them, the permit is going to be to provide this treatment for water quality. Their requirements to have this structure to be there, 90-second residence time for the flow, which is 90 seconds multiplied by 15 CFS is approximately 1,300 cubic feet. So that was their requirement. FDEP has requirements for the underground injection. They have a requirement that you cannot inject water to such a degree that you cause mounding or you threaten public water supplies.
Right.
You don't have here public water supplies. There is limitation of the height that can be applied to the well. It's limited to 7.5 NAVD, and that's why we have this groundwater model, so to ensure that we're not going to exceed it, and then we can permit it. So these are the permitting
There's a
requirements.
current interesting study that's happening right now with Dr. Walsh, I think in Miami-Dade County, with subterranean, Black and Beach is on that one, I believe. Subterranean flows of water coming in, looking at the plant and looking at all that. I'm not sure if there's anything there of value to you.
Yeah, they do studies also about the salinity,
Looking at-
salinity intrusion.
Yeah.
I'm familiar with that. With they do they actually study the fraction of the fresh water that gets discharged in the bay and how much of this is phosphates, and so they look into that.
Is there a concern, because I have read some chats about concerns about pollutants getting into into the aquifer? What can you speak about that?
So for major pollutants that come from urbanized areas,
Right.
these are nitrates if you have agricultural.
Right.
From very strongly urbanized area is phosphates, basically from the lawns and people that use enhancements of the lawns. So the nitrates is it's basically not sorbing, and it moves directly through the aquifer in most cases, unless there is a low oxygen condition, anoxic condition, then it gets denitrified. But for phosphates, there is certain percentage that can possibly get sorbed to the aquifer. It's not very high, so there is some treatment, although we cannot call it treatment. But this doesn't enter the permitting process.
No, I know. I'm sorry, you were talking about permitting, but I also triggered on that question. So
yes.
If you need to finish on the permitting, go ahead.
So the majority of the pollutants are sedimentation, total suspended solids, metals. Like for metals, they can sorb in the aquifer, on the soil particles. So that's a potential pathway to reduce pollution in the bay. And the groundwater moves extremely slowly, so that's another benefit. If you inject it in the well, it will take like tens of days to reach the aquifer, because there is a continuous movement back and forth. So there is no direction of the flow, particularly for the island. You have external tide when it goes up, the groundwater moves inside.
Right.
When it goes down, so there is no movement as a regular aquifer.
Yeah, no, I was asking because, and I'm just trying to respond to the public on this, but just to get a feel, because there was some sentiment out there that stuff got into the well. It could not just algae or whatever, but other stuff that could affect the functionality of the well.
We have two, if I could, George, we have two very deliberate agencies looking at this, Miami-Dade County RER and FDP, as you mentioned. And when we did this permit process for the well down at Beach
Ocean
Park,
Lane.
it was a 7-8 month process that they went through. Do you all remember? So this is something they take very seriously, and there's many things that we have to do to make sure that we meet that. Their standards are high, and that's what this design is going to have to meet those standards.
And how long do the wells have to be reproduced or have to be reworked? What's the life cycle of the wells?
So the life cycle, there is different data. The well has automatic control. They will trigger when they have to be flushed, rehabilitated. There is automatic control that triggers those. So we kind of provide detailed description in this report, but I would assume, based from other areas, it takes like several years before they get back in the.
Okay, is that also included in the life cycle maintenance?
That to be.
Great. I'm just great. That's it.
So when you're talking about reworking the well, just mechanically, you're pulling the pump?
No, they're separate.
Okay,
It's just not in service. It's open at the top, and it's
side.
what you do for regular wells.
Same thing you're doing now with this film.
Yeah.
I was just thinking it was like a workover rig. I thought they're going to bring a workover.
But in general, when you're injecting in the wells, you have ability to control. For example, if you start experiencing high pressure, that indicates some clogging. So that can be more or less. With gravity wells, you don't really have this control because you have no way to measure.
You have no way to measure the back pressure.
Yeah, the back pressure. Exactly. If you're fine, I just wanted to bring here another backup power, because Ed said, "Oh, you're recommending two
It's a common sense.
generators. But I wanted to mention that as a part of our due diligence, we're looking at the data. How much is what's the indication that there's going to be power outages? And these are combined probabilities. So there's a joint probability. If you have one probability and then you have another probability, the outcome of both probabilities is multiplication. So if you have design event that's 1 in 5 years and you have failure 1 in 5 years, then the joint probability of this occurring at the same time is 1 divided by 25, so 0.4%. So we're looking into that. So once we get understanding of the, but we're trying to do the due diligence to get the data from, and then we can put it together and we can say, okay, so this is your probability, and then it will be, I think it will be ultimately up to the council to decide, do we need it or do we not? Because we can look at the risks that brings this, or look at the probability. We're not necessarily fans of, I'm not a big fan because I've been dealing for a number of years, I've been dealing with the airport, all the generators at the airport, as my company is doing inspection there. And I can tell you this is one of the worst places at the airport. There is 75 generators, backup generators. There's 75 types of backup generators, and some of them are from the 40s. They're like as big as this room. They require fuel, and we estimated that you need 300 gallons. Typical case scenario is 300 gallons of diesel fuel to be located. This one would be the appropriate for 15 CFS. This would be the appropriate size. This is the type that you could use. It's 10 feet by 4 by 7, so it's pretty large. And then you have to raise it on a high, so it will become pretty much the highest point in the island if you do it.
We already have 2 of them. You can just go out there and look at them.
Yeah, we know what they look like.
Yeah.
Yeah.
I mean, that's like a.
Do we have 100 kWs?
77.
They're just slightly smaller. The next size is basically almost the next size now. They're 77 kW.
Similar,
We know what they look like.
similar for
Do the county run them every week?
They have, yeah. They have to run them, and they cannot run
15
them more
minutes.
than 15
Yeah.
minutes. And no, they have
That's
like
the
a.
only time that they will run is when they're.
And then you
understand.
We don't have
And
to
then
keep
you have
going
to
over the
report them
generators.
to EPA. Then you have to report them as emissions.
George,
Doesn't the village have statistics as to how many times underground power have gone out? I mean, I know this year we had an issue with the feeder lines. I'm not talking about this year, but before this year, I don't remember ever hearing the underground power going out.
we met with FPL and
I'm sorry.
we met with FPL and asked them for reliability data specifically for the overhead versus underground. They don't have as good of data as we would wish, but they did give us general information on the reduction based on undergrounding. So
That's not the question.
Yeah.
Question.
Yeah.
So you don't have they don't have the
they
information.
don't have.
They don't have that information. They're tracking exactly how many times overhead to underground.
We asked them at the conference the last time, and they basically said they don't have that data.
Correct.
Yeah.
One more question. Does the pumps work without, if the injection pumps are not working?
What?
No, it's very low efficiency because there is no head to drive.
Backdoor gravity wells.
Yeah.
Yeah.
And it would have to.
No,
be
you're lower
pump.
probably.
It'd be just like,
You're probably lower.
it would be just like what we have now.
Yeah, you have, yes, and then in addition to
You-
the head
No
losses.
conveyance to
The water also has to flow
addition
through
to
the
head
pump
losses,
and through the
you have to roll
manifold
the valves.
to go down, so gravity,
So it
would be
would
slowed
actually
down
be worse
there.
than
So
just
you
gravity
have a
loss,
loss.
because you have, yes.
Assuming that.
So
pump
that's-
power
Because you can't,
time,
you can't
the
get.
exact time that we had.
Which is the risk analysis that you have to compare on it, is yes, probability would be low, but if it does happen, you're in a worse condition than you would be otherwise.
So how many, excuse me, when does it become really necessary to have the pumps running? 4-inch rain?
You have, for 4-inch, you have minor flooding. and you have 20 times per, for the last, if I remember correctly, for the last 10 years. You
20
have
times,
20,
4-inch rains.
yes. And
So
about-
that's when we really should have the pumps running. Okay.
Basically, whenever.
And that matter of so many hours within that time period. So
It
each
will-
time,
Where are they gonna run?
that's very, very small occurrence.
Let me ask you, where have you put this system in before?
I have in Ventura, I have another project, and I have been also designing, because this is typically a large activity with multiple different designer, electrical, mechanical ones at the final.
So it's Aventura is one place?
Yeah, Ventura, and also in
Is Aventura for the city or Aventura for a private client
for
or
a private, for a small community, we placed the pump, and also
any cities done this anywhere?
I've been part of the design of in Miami Beach in some of the facilities there, and not Miami, sorry, City of Miami.
City.
This is similar with the design for our garden district.
Yeah, that is slightly different configuration.
You know, there's a lot of positive things about this design, and there's some things that leave me kind of thinking a little further. Perhaps because,
I can't hear you.
yes, there are good things in this design, and there are parts of it that leave me thinking a little further about it. I think overall, we're looking at just a different way of presenting pipes, pumps, and outfalls, right? AECOM design a normal, standard, typical Miami-Dade County system, pipes, pumps, and outfalls, and you're designing pipe, pumps, and injection wells as a disposal system. The thing that we're modifying is a disposal system and the capacity that that disposal system allows us by permitting and whatever other physical constraints or limits it may have. I think it's a great opportunity to do something modular in a small community that tries to keep its identity, that does not want to see massive things. And plus, really, when you think about it, we have, I always been asking this question since the beginning, do we have enough bathymetry? Do we have enough head? Do we have enough space to put in a massive pipe of that size? And we were looking at expenses of, building the seawalls, et cetera. I mean, to digress, but then again, I'm not for that. I don't want to discharge a drop of water on Biscayne Bay. So the fact that you're discharging it through a through a well down, I think it's a great idea. But the thing is that what concerns me a little bit is the proven fact of it. The mayor just asked, where did you do it? And clearly no municipality has picked this up yet. It doesn't mean that they shouldn't. It doesn't mean that they shouldn't. And it doesn't mean that it couldn't be an opportunity for smaller municipalities to do so, because right now we only have one method. The thing is that we need to be really conscious of what we're spending and how much is this going to cost us, not just in infrastructure, but also in operation and maintenance costs, and how much dependability will we have on electricity and power for this system to run. Those are just my main concerns, that's all. And I also think that you're tweaking the road, you may be tweaking the road too much, and I'm not sure whether that you can achieve that physically on the road. Not things that cannot be fixed. I'm just providing that as a point of view, that's all.
Hold on, sorry. Go ahead, Nancy. 1 second, please.
A long time ago, over a year ago, when I first started campaigning, I had a meeting with Roland, when we were talking about the garden district. And I asked him, why can't we do what we're doing in garden district in zone 1? And I believe, correct me if I'm wrong, Roland, that he said we couldn't because we would need too many injection wells around the school, don't have enough room for them, and there
The
would be
spacing,
mounding. And there would be mounding, okay? But
Mounding.
this sounds like, this is a project that's more akin to what is in the garden district. So how are we not creating the problems that Roland was talking about with your system?
Who was talking? I didn't hear you.
I'm sorry?
Well, I think it's not Rowan, he was probably relaying AECOM's concerns. I think that's probably
Okay,
better
well,
way
I
to
mean,
say
I got my information.
Yeah, I mean, Rowan, I think
He
would
was my
imagine he's
expert at
passing
the
on
time.
AECOM's.
Right.
There was a white paper that was written that talked about
Yeah.
40
Okay,
plus
so
injection.
with your system, what about your system avoids those problems? That we wouldn't need as many injection wells and we wouldn't have the mounding?
Yeah, so to answer, I don't think, like I read the ACOM white paper, they never rejected the injection system. They said that it will require multiple wells, and the way they calculated is the way they calculated it. And they were referring to 50 or 60 or something really large number, I don't remember. We had a different approach in the analysis. We're using an integrated surface and groundwater model. So that shows you the exact mounding, so we don't hypothesize about the mounding that is going to occur. And as far as I know, not too many mounding analyses are present with the groundwater model. I can tell you because I've been in lots of different projects. Typically, people assume certain elevation from FDPs given 7.5 for a coastal community, 6.5 ahead, and then they say, okay, if you pump more, but this has not been shown. Like we are showing this with the groundwater models, which we will be submitting to FDP. So that's one difference. We're doing the analysis directly with the groundwater model. And in terms of the multiple wells, they also had a different approach. Basically, the assumption was, in this white paper, is that you're generating 3 CFS per acre of peak runoff. And then you multiply this by 100, for example, acres, and you get 300 CFS. So that also is not the approach we took. And the quote from the paper is based on our experience, based on, other projects. We have a detailed calculation that takes the topography in details, like we have a 5 feet cell. So we're looking at movement of water on the surface, on the roof, and how this enters the properties and where it accumulates. So it's a different approach. I would say it's more accurate in terms of technicality. Their approach is more conservative. Our approach is more accurate, like in terms of applying all of the aspects of how the water flows in the unsaturated zone, how it moves to the aquifer, how much flows from the roof falling on the ground, and so it's a little bit different approach.
Can I add one thing? Want to explain it all? When they did the white paper, they were talking about a system that was going to take 3.2 inches of rain per hour.
That was going to be my next
Okay, and
question.
that's why you had all this intense pumps to do that. Then the next proposal was 2 inches. And then what we approved was a 2 inch, but a 1 inch, because you expand past 2 inches. So as a result, their numbers were all based on something that we weren't really going to consider.
That was going to be my next question.
The level of service.
It was level of service, but it's also volume of water. I mean,
Well, this was the volume of water.
He's calibrated
3.2 inches.
he's calibrated his models through actually the science of what, by doing liner type.
Yeah, but this was 3.2 inches
It's double the
of rain.
It was 4 times the amount of
Yeah,
water.
per hour.
Yeah, so by that point, we had already screened out the 3.2. So we were down to the 2, which,
Not when the white paper was.
yeah, no, it was, yeah. And then we were at the 155 CFS requirement.
155 CFS, 3 CFS per well.
155 was a 2 inch.
Still,
Yes.
22 wells.
But
22 wells.
77 was the one.
Nancy, do you feel like
But
your answer was, do you feel like
I
you
do,
got?
I do.
Okay, good. Luis, I think you had a question. Good?
If I can also add,
I'm gonna ask
the both of our approaches are not extremely different. They are differences, but their decision to use a centralized system was for long-term sustainability, for sea level rise. If you look at, that was really their major, and also as, and design life for
30 to 50 years on that. This doesn't have a very good design life.
And I think that's important because I do want to bring this back to also understanding what your system entails so that we're all on the same page, because we talked about a lot of different components today and there's a few different variables. But moving forward, Giorgio is finalizing the design, and that final design is
Well,
going
it's
to come
finalizing
in.
the concept.
What's that?
Finalizing the concept.
Concept.
Yes, but yes, it's not an engineer design, but the concept that then we can evaluate. So I want to make sure that we're all on the same page on what we're going to be evaluating. So we're going to have the 6 injection wells. We're going to have the pump stations. We're going to have the water hydron separators, right? We're going to have at least a baseline of new catch basins and conveyance system. My understanding is we will include the CCTV inspection because that's more or less required in order to know what the existing, because this system is based on using the existing system. So the modeling that he's done has to be based on what the reality of the existing system is.
So when we flush the pipes, which Chris does on an annual basis, and he has the water X amount of gallons going through this pipe, and if they go out the other end of the pipe, we know that there's no breaks in the pipe.
You might know that there's no breaks in the pipe, but you won't know if there's a crack with infiltration and water coming in. So
And
your
if there
system,
is?
his system might have to.
If there is?
I'm sorry?
And if there is, so what?
The problem with infiltration is then you're not pumping out the water that's on the surface,
Well,
you're pumping out the water that's in the
But
ground,
obviously
and
then,
you're just doing
then
it.
obviously, if you didn't pump anything, the water would keep coming out the other end, there's infiltration. Correct?
Well, there's water coming out the other end at all times. It
If
doesn't
there's
stop.
infiltration.
Well, there's infiltration and with the tides going up and down, we see it coming in and going out the other end, yes, in the outflows.
This is the time to have this
I think
discussion.
we should do that. It's $500 million on the big scheme of things. It's not gonna move the needle on the conversation. Really, in the big scheme of things, it's not.
It seems like good practice, but
Yeah, but we should include it in the, because in my opinion, it's part of the scope of work. It's $500,000. It's not gonna move the needle on this project, right? I mean, the big scheme of things.
I mean, if this is the backbone upon which we're building, I think we need to know that it's going to be an adequate
Well,
backbone.
we've already done it on Zone 8 anyway, so is that quote that we got for everything?
No, that is just zone 1,
That's just zone.
zone 1. Mike, you went in, I also, and I'm going to put my glasses on, but I don't think I see anything about roadways in these 5. Because you're on slide, well, you're on 1.3, I think.
I'm on 1.4.
Okay. Okay, on the roadways it is. So let's make sure that, they see what you're talking about before we jump to the criteria and see if they have any final questions.
Can you go back to 1.4?
No, 1.4 is what we're looking for. He's got the things at the top. Just make sure that we're clear on all the different components that he just talked through.
In number 3, we're saying we need to add roadways.
Right.
Right.
Which is
Yes.
sloping slash raised.
Sloping,
Now,
gotcha.
now, we understand that he doesn't know exactly which roads and which part. This takes an exhaustive study and survey, not exhaustive, but a substantial one more than what his scope of work is. So, but there has to be at least some sort of, Giorgio will do a analysis of what he thinks is appropriate, and then that will be taken into consideration.
And Georgia just asked a question. I just want to be clear. I'm clear, but I want them to be clear that the program element 4 is outside the scope, and that would be additional capacity if we so choose to do it.
Yes, that's the correct way to explain it, and again, I would add for emergencies and for extreme events. That would be the rationale for this particular item.
And you could tie that into the recommended system by pumping laterally instead of.
In the ground. Yeah.
Okay.
Mike, so do we want to make sure that we have a number for zone 1 and then we have for zone expanded? Because those
Yes.
are 2 very different things.
It is, and we need to see the hydrology on both of those as well.
By the expanded one, we're looking at a substantial potential savings over the amortizing over a lot.
And that's why we want to make sure that we're clear on this, because will affect each one of these evaluation criteria because it's additional cost, but it's also additional benefit.
And Mike, I would
So
also
we need to make sure
suggest
that,
we do a cost per house.
Yeah.
Also, so that we can see what because I will tell you what, since every single pump is inside the existing zone, our cost in the pink area will be not that much, and so the expansion may be well worth it if we do a cost per
I
house.
think the expansion.
But in order to compare apples to apples,
Yeah.
we gotta make sure we just do zone one.
Am I correct in that the expansion area will get some benefit, but it won't be the same actual level of service as the real zone, the original zone one? But that ultimately, if we decide to do another zone, that those areas would be brought up to the same
Yes,
level of service?
yes, that's correct.
so for us to evaluate that, we need to evaluate that as a whole and then evaluate zone one as a whole. So they have different levels of service between them, and we can evaluate both of those as well.
But when we talk about level of service, guys, we gotta be fairly detailed, okay? So
Yeah.
we don't have this, 80%. If we're gonna do a number, it's gotta be a percentage of something or an actual number. It can't be, we
It's
believe it's gonna be X.
basically flood depth, I think is what we have to look at, is the best
At
flood
time.
depth. So flood depth over time,
Just so we can do
Consistent.
a consistent pneumatic comparable.
Well,
I don't want subjective comparables, we're in mathematics.
what we've been trying to establish for that baseline is exactly what you're speaking of, is what are we looking at flood depth over time? What's the passability of vehicles throughout the streets? I think that's probably,
Yeah,
I mean,
that's
that's
the
what we-
criteria, yeah.
Good. And so do we wanna move on to 2B, guys?
just
ask-
real quick, I want to make sure that we're still on the same page.
Yep.
So for backup power right now, we are gonna have future backup power for your system. The ability for future backup power. We've talked about, different options moving forward, but I want to make it clear because as he puts together his final layout,
When we talk
looking
about backup power, we're talking about
It's optional now.
yes, so that would be an optional, much like the force mains to the outfalls.
So optional generators, is that what we're talking about?
Yeah.
Okay, yeah. I mean,
We need to be clear
If
on
you wanna put as a line item option, it's fine. I mean, it doesn't make a- Joe, you had a question?
Yeah, let's go back to the road raising. The road raising is a huge element, is a huge element in the AECOM. Can you go over what you think that road raising looks like? And going back to Tom's example here, I mean, the issue is moving water. Both systems need to move water. Why would one system require a lot of raising roads and yours less raising roads? Can you elaborate a little bit on that?
So raising roads is decision, for example, that the hypothesis the sea level rise is coming up and is going higher and higher. So adaptation is a consideration for raising roads. Adaptation for future sea level rise, and you can might as well raise it with 1 foot. I believe the AECOM was raising the roads as to 3.2 feet.
Not that much.
Not that much. I saw different documents. Maybe yes, there
It was
is.
like 24 inches at most of the high parts, and those were intersections. But a big part of it is because they also included
Yeah,
a
the black base
system,
stuff.
which allowed it to reduce the height of the road raising. But
There's also, Mike, a
It
big
was also
substantial amount
expensive.
of cost of harmonizing to the.
that was a very large part, because now you have driveways,
Harmonization is
landscaping.
massive.
Oh, they were digging up the roads, put the
Exactly,
pipes in.
exactly.
This is direct boring underground.
Exactly.
So obviously, you're not going to repave all the streets.
No,
Or you
the-
would.
So, but guys, when we're talking about road racing here, we're probably not using an adjective that is appropriate, okay? Because what I believe Giorgio is discussing is he's saying that we have to do some modifications to the roads in the areas of the catch basins to better make those catch basins efficient. He's not talking about going in and repaving entire streets. He's talking about going to specific catch basin locations and saying, okay, what do we need to do to make these catch basins more efficient? So let's make sure we're talking about the same thing.
I want to make sure though that what I hear the mayor saying is if AECOM says we have to raise it so high, how is his system not have to raise it so high.
Right.
I think that's what we're
Because
saying.
we have to move the water.
So the macro
Yeah.
houses, so we can't raise the roads, no matter what we want to do. Because eventually, you will have to raise roads, but you can't do it now with 300 or 400 macro houses, because it'll all flood.
You raise the roads, all of our houses are gonna get flooded.
Well,
Macro houses. Yeah.
I'm not sure what you guys are talking about.
Well,
no,
okay,
it's not necessary.
again, let's go back.
Let's ask Giorgio.
No,
Yeah.
but I think, I'm sorry, Mr. Mayor, but I think there's I want to extract a little bit of value because we seem to be putting it off, and I don't think it's something that you want to put off raising the roads. Houses are being built based on the new floodline elevations.
Right.
Raising the roads is something critical because eventually you have issues with harmonization with those roadways. So I don't think we should be so quick to say that roadways that should not be raised. Roadways should be raised. The thing is, eventually, and the question is when.
Yes.
Not part, no, but what I think what's happening is that my concern was, just a quick thing, is that we were doing tweaking to get the flow into the well. And what I'm saying is that that's a great and noble thought on paper, well, you have a slide rule and a pencil, but that's not gonna happen in the field. So if we're doing that, we're gonna reduce 2 inches here and raise 3 inches there. It doesn't seem to be like we're gonna meet the county requirements. What are we planning on doing? That's really where I'm.
Okay, can I go back to
Sorry,
my, so can you explain a little better so that we understand what your concept of raising means versus what we've heard before?
Yeah, so to answer this question, because we talked about the road raising, how to, in general, everybody is in the opinion that as you have a sea level rise and continues, if it's 6 feet after in 2100, that will make it impossible not to raise
Okay,
the
but
road.
we're not talking about that.
So for the time being, we're
We're
looking
talking
at,
about how efficiently your system can be in terms of getting rid of the water.
so hydraulically, the pipes, which is the main conveyance, is at minus negative elevation. So the water flow underground, as long as you have the correct gradient. If you, so it's at -2, -3, -4. These are the inverts of the pipes. So hydraulically, as long as you have the gradient, doesn't really matter where the road is, or unless you have a tidal that's influx from the outside. For 2050, we're looking at you're going to have approximately 1 foot of additional elevation. So at this point, do you really want to start raising the roads if it's only 1 foot, or you want to use it as an adaptation strategy once it starts exceeding? At what point, which Fernando mentioned, at what point you want to start raising the roads?
Okay, but in order for your system to work as efficiently as possible, you don't need to raise any roads?
Not to raise the roads, resurface them and.
Okay, well, and obviously when you resurface, if the road's been whittled away, it would have a little bit of rise, but not, you're not talking about anything significant.
No global raising.
Okay,
Preserve as you have right now the village and the roads, and if you have location that's blocking the flow, maybe flatten it. Allow the water to proceed further.
so my question not getting through, or?
I think there's 2 questions going on.
Okay, go ahead.
So Giorgio, I think what Joe's discussing is we're talking about in the ACOM model, there's $20 million that was
huge.
allocated to doing road.
I want to be clear. There is about $6 million of road raising. The other part is landscaping, harmonization, and black base. So actual road raising is about $6 million.
The road work.
Road work.
Road work, yeah,
Well, that's because you're tearing down the road.
to some degree, yes.
There's $20 million a line item of road work. Some of it's landscaping, some of it's, okay.
About half of it was landscaping, which is a significant portion.
Significant amount of money.
Yes.
In, Giorgio, in your current design, we have to possibly modify the roads to better utilization of the catch basins, okay? Is that what you're saying?
Yes.
And And I'm not asking you for a number, but
Yeah.
next week, or in April 7th, will you come back with a number that you can recommend that we can use as a budget number to allocate a cost associated with that?
He's gonna
So
have
we
to,
can
that's
compare
part of his
those two
cost
things?
estimate.
Okay, I think that's what Joe's looking for.
Oh, okay.
But I
So-
think it's also, look, I'm with the mayor, and also I'm gonna, as we, obviously, we're not gonna decide it tonight, but I'm wondering how we won't have to raise some road. We got pretty low roads, particularly in and around the school. And that's, I think we're gonna have to give them a pretty clear answer on the 8th, and obviously a cost associated with that. Because
So we've
I'm
been
struggling
looking at-
understanding.
He's putting in new catch basins, he's obviously put them in the low spots.
Right.
So we're not gonna have to grade, in other words, you got a low spot, putting 100-some catch basins, that's how he's gonna pick up the water. Once it goes underground, it's gonna flow.
And if you look at the analysis, if you look at West Master Drive, Chris, you regraded the road.
Right.
After you regraded the road, the flooding on that road was substantially different. I mean, Brett, you remember?
Chris doesn't take credit for that, that was Jake. But
Okay, well, whoever did that, Jake did it, whoever did it. And Brett, you were on council when that happened. But the flooding on our street dramatically changed, just by raising the Crown Road by what appears to be.
Here's the only crust.
Yeah.
How? Because it pushed
Because
the water onto.
water goes to
The water went
onto-
they recrowned the road, so the water now rolled down the street
Into your
versus,
Well,
property.
we did two things. We
Catch basins.
no, the catch basins.
Okay.
we sloped the road and we also put curbing to force the water to the
Curbing,
catch
yeah.
basin.
You directed the water to the catch basin. with
Correct.
some
But isn't
curbing.
that what Giorgio's talking about doing?
Exactly.
Yeah, so crowning the road, down the middle of the road, it was raised higher. We did some of that with the recent pavings also. So it keeps the water flowing to the swales, over to the sides, and it'll direct the water.
That's what they did on Island.
But just make sure that we're clear though, the immediate flood control was intended just for everyday flooding. It was not intended for the 5-year storm.
No,
So,
sure.
yeah, so that's why I just want to make sure I'm clear on that.
Are we all good on the roads, guys? Okay. Steve,
Yes.
do we want to move to 2B? Because we're at 7 now. And
Are we comfortable? We think we've got some bandwidth
I
left?
don't know, I think we've got to
I don't think we're at
something.
7. I think we're at 8 because that's still
Oh, I'm
Yeah,
sorry.
daylight savings time. Did I say if that was only an hour? I think that was pretty impressive.
Yeah,
But
sorry.
Chris, your turn. Get it.
Do we-
Chris is our official clock changer because he's tall enough to do it.
Figured that too.
I think it's important because, we're going to walk through and, again, going back to what I said at the beginning is that we are now, about a month away from his final deliverable, which is on April 8th. And what we want to be able to do at that time is use these criteria that we have here to provide you a recommendation of comparison. And then that would be a primary part of that conversation, how you feel in terms of the comparison.
So if we could go through that criteria, Mike, are you going to lead? Mike Kuda, are you
Yes.
lead?
Mike's going to walk and then I'll join on.
Absolutely. So,
Before we get there, I just want to make sure nobody else has any additional questions. Nancy, any additional questions? Fernando, any additional comments? Joe, anything?
We're good.
Ed, anything? Anybody on the audience have anything else they want to ask before we move on?
Just one more question.
Yeah.
Give him the mic, Mike.
Oh.
It's hard to hear. Give him the mic, Mike.
Very simple. Thank you. It's a very simple question. In the slide 2.3, if we can just know what is the lowest terrain elevation inside the polygon, where is that located? And what's that elevation?
Okay, so the 2.3
Your groundwater slide.
groundwater slide, okay. And this is the amount of the groundwater or the terrain. So the lowest is 1.51. Yes.
And this elevation, is elevation above the groundwater, or table, tide?
So this is the head of the groundwater. That's not the phreatic. There is a difference between phreatic surface and the head of the, this is the head, so it's not the phreatic surface. The phreatic surface is still below the ground. But when you inject, you're creating artificial pressure in the ground, And if you put a piezometer there, it will measure that elevation. So, is that, because I think, you know.
No, that's perfect. That was the one.
Okay.
What is the lowest elevation in that polygon?
In that polygon is
No,
1.5.
The surface, where?
Oh, it's all over the place where you see roads. They're at 1.5 to on the roads, because the parcels are there. Most of them are built, but the roads are the lowest. Basically, the right of way is the lowest point in general.
Except for Eric Lang's house.
No, Joe's house.
No, actually, Eric's is lower.
Eric's is lower than Joe's house?
It is.
Eric's house is lower.
Yeah, because at least the mayor kind of built it up a little bit. It's just in
He's got a
front of the
berm.
mayor's
He's
house.
got a
that's
berm,
the
he
back.
just can't get out of that driveway until the water ceases. Go ahead, Mike.
Okay, so what we want to do is go through these quickly. We'll talk a little bit about the subcategories, and then I want to elicit your response and your feedback. Understanding in the next week, 2 weeks, that we can have this finalized so that when we get the final report, we can go ahead and do these.
Councilmember London is not here.
I think he just went to the restroom.
Okay. All right, you got one?
I think the first one is pretty self-explanatory. We kind of already talked about it, technical performance. This is technical performance of meeting the criteria that has been requested. So we understand that ACOM was for a 10-year storm. It was for 2060 for no intermediate high. Giorgio's has a different design criteria. The idea is, does it meet that design criteria? How well does it meet that design criteria? And then how well can it be adapted? How well can it be phased? These are things that we're looking at. Some of these kind of cross over, but it's going to be how well does it work?
So
Is it
Mike, are you
redundant?
gonna use a number like 1 to 10, or are you gonna use A, B, C,
Well,
D?
we'll talk about, we have a slide where we talk about how we're gonna rank it. Let's talk about the criteria itself. And I think also here for this one, we will ensure it just is the same outline, correct? Same zone structure, same size.
Yes, for zone one.
Yeah.
So,
And and I think we do have one that is expandable, if not, we should.
Yes.
That would then that would be added, because both of them are
Both of them are,
expandable.
yes.
But obviously this one has a little more detail
Mhm.
on its expandable recommendation. Expanding.
And this has been shared with Giorgio. This criteria has actually been shared with ACOM, so they're both looking at it. I want their feedback on their system so that,
And have we elicited AECOM's input on this?
yes.
Okay, because I would like to see what theirs, and then you're kind of the adjudicator on this, you being Black and Beach, not you personally. But I hold you accountable.
ACOM's for theirs, Giorgio's for his, obviously, but yes. Next one, environmental risk and climate resilience. This is the impact on overall sea level rise, extreme weather events, routine weather events, ability to operate with the conditions that we have and the conditions that we may have.
I think simply what we're trying, I mean, it's a little bit more than this, but generally speaking is, so we ask AECOM to design to a certain level of service with certain design criteria based on certain climate situations. We've asked GIT to design to a lower standard. I don't mean lower in terms of quality, I'm talking lower in terms of environmental potential. So this is, are we willing to accept that risk? Or what is that risk if we design lower? And then we can ask the question, are we willing to
How are
accept
you,
that risk?
so Steve, how are you going to make a judgment of that? Because there's a lot of subjectivity associated with that type of information, and subjectivity is generally based on a lot of opinion.
But I think, so I think we have to,
And I think we gotta be very careful with opinion and subjectivity, because it allows for analysis that is by discretion, okay?
Sure.
yeah, but I think what we're, and I don't disagree with you, but also we have to acknowledge it somewhere, right? The fact that we ask them to design at a different level, and because that does lead us to make a decision on what risk we're willing to take, right? And we'll do the best we can to make it objective.
But Steve, we could go back to ACOM and say, okay, by the way, guys, redesign back down to this additional number, and there will be a substantial expense associated with that, because they basically have to rerun all their information. But we did ask them to go back and tell us how much water they had to move based on the same criteria that we asked GIT to.
So,
And they came back and with a value, but that system would basically would have to be highly valued engineered to
No, they could do that with a 3-pump station, or 3-pump station instead of a 6-pump station.
or,
Because they could run at 77 CFS in the pump station and be expandable to 6 pumps, which would get them to 155. That's also why we have that third point in there is adaptability and future expandability.
To me, that's a key question, future expandability.
how far in the future, that's the, we're talking 2060, 2070.
but that's how adaptable would it be?
Yeah.
So you can add more pumps, you can add
Can
more
you
wells, you can
add
add
more
more
lines
collection
to it?
systems, you can raise roads. What is the impact on each one of these alternatives?
I'm trying to be argumentative, but we had a conversation about this a while back where we said, okay, can we take the ACOM system and expand it over a greater volume of houses, okay? Which is what basically we've decided, done with a little bit additionally here, right? So if we could do that same thing through a forced main system for the rest of the island and push the water to the pump station, we can amortize it over a greater amount of houses. We asked that question, and basically the response I think I got back was, that's not really feasible, and if
No,
you,
that's not what they said.
okay,
It is feasible.
okay, but so what's the cost to do that?
No,
Well, we never asked them
got
to do that.
I mean,
Yes,
that's
not
something
we
that
asked them to do.
we have to do, because you can't do that and then compare it to this, and you're not, because that's not apples to apples.
But we're not comparing the cost of it.
Was that everyone was designing to the same
Well, that's,
parameters, I thought.
but that's why I'm saying this conversation of expandability and this conversation of subjectivity leaves a lot of inferred information, right? I mean, and that's dangerous.
But at the same
At some
time,
point,
it's
we're gonna try to-
dangerous, hold on a second, it's also dangerous not to acknowledge risk though, too.
Okay.
Right, and, if those end up not being quantifiable, we'll have to qualify them as risk statements, and.
So how do you qualify something when you're designing to 2070 versus 2050? How do you qualify that?
We don't have Macco houses.
Well,
Raise the road.
well, if we,
In the future.
we could take either NOAA intermediate or NOAA intermediate high and calculate the difference in the potential groundwater. And identify that as being a risk. Now, we wouldn't necessarily be able to put a cost on it, and I don't think that's the intent to put a cost on it. It's something that we're acknowledging that could be a potential risk.
Steve, I understand the goal. I'm just trying to remove the subjectivity out of the conversation. So because I think that puts a lot of.
So,
But I think when we're talking about the future, it's kind of hard not to have some level of subjectivity. You know what I mean?
I think, though,
I think
if I
Mike
may,
wants-
if I look at this into the future, right, because we kind of all got bogged down with the cost, a heavy design, and now a new idea to try to fix the cost primarily, because it hasn't been really about, the flood is the flood, but the discussion here, the big girl in the room is the cost. So let's talk about it, because what happens with that, the reason why I'm stating that is because we lose context, and the context here has always been about sea level rise. It has been about making the community resilient. It has been about looking in the future and prosperity and making a system that works. And I'm all for new designs, and I'm all for great ideas that fit that model. Why not? And I'm saying because the reason I'm going to bring this up in Miami Beach, we did this in 2009. I spearheaded that with CDM. And it was the first stormwater master plan to take into consideration sea level rise. What I said back then, so Mike 40 back then, what I said was, I want the city to divorce itself from outfalls and inject down into the aquifer. I got denied that by Durham. I don't know what happened. So then CDM came with an idea, and I would suggest, or I would encourage everybody to look at the 2009 stormwater master plan in Miami Beach, which was to come up with a train system, which had to do with let's try pumps, let's then add, pipes, let's then add systems. I mean, this eventually will end up being something that will be a system that makes Key Biscayne resilient and makes Key Biscayne resilient towards sea level rise and climate change. This has always been our position. Nothing has changed. We've been thrown off against the wall because of the cost. But I don't want people to lose track or vision of what the initial plan was. So can we work something out? And I'm not saying put the two designs together, but take the best out of each design and see how that would work. Because then we happen to have both of the best designs in the sense that we have something diagnostic, something that's modular, something that could be implemented tomorrow, or we have something that could be implemented, the next week or the following week or whenever we have the funding.
Well,
Let's not
I
lose
think
the vision.
he's
Let's put the
getting
two-
at that in his program element number 4,
Right,
where he showed that force main capability.
right. Right, yes, and yes.
To a degree. I know
To a
it's
degree.
not what you're saying, but it is his attempt to initially
Yeah.
consider.
Let's not, I think what we need to do is kind of have a little bit of a brain trust here and understand how we can put both designs, the best of each design.
Well, the manifold system.
The
Force main is
that's
exactly
beautiful.
the redundant
Yes.
thing that you're looking for.
Yeah, I think that's a great idea. The manifolded system, because that provides storage. You should be looking at the recirculation. I want to have a chat with you afterward.
Yeah,
So
but Fernando,
recirculating that.
but we're still back to this, situation. If we decide to go and use the force main system, we're putting water into the bay.
We're putting water into the bay under extreme emergency
Right, but
conditions.
so we have the option to do that.
So we
So
gotta
that
move
is,
forward.
in my mind, that is the redundancy that you're looking for.
Yes, but I think that the pipes, the conditions, right now we have 12 and 18-inch pipes, correct? And the minimum is generally 24, am I correct?
Yeah.
Okay, so eventually, and I'm not saying tomorrow, and I'm not saying part of this design, start looking at 24-inch pipes or larger pipes, because you're gonna need them. You're gonna need them to move the water. And if you can recirculate that water, you'll reduce your peak, and you'll still be able to inject at the rate you wanna inject.
But guys, down at the end of the day, it's the cost per home,
Yes.
okay, over the life cycle of the equipment, which is what the residents are concerned about, okay? What's the return on investment per home over the life cycle of
I
the equipment,
agree.
right? I mean, that's kind of what we're discussing, right? And everybody's getting kind of frustrated about it, but that's really what we're discussing. So we ran into a situation where Joe said, hey, guys, this looks to be very expensive. Is there an alternative way to do this for less money, okay? Which it was really just saying, how much can we do with less per household, right?
Yeah.
Okay. So now we have a system that theoretically is potentially is expandable with the ability to put a force main program to it, okay, as an option. The question really is this good for 2060? Is this down to 2070?
We don't know.
We don't know, and that's the part of the subjectivity conversation I would like to take out of the conversation.
But
But without
we,
losing,
you can't quantify it, but I think we have to at least mention it, and will we accept that risk? I think,
Well, isn't that how we got here in the first place, that we were hearing from residents, why are we planning out for 260 and 2060 and
no,
2070?
I personally, as Councilman Vasquez said, it was about money. Look, I don't think the
But
average,
that's what was
I don't think the
driving
average
the money.
resident really understands the difference between 2050, 27, 20.
Well, the cost.
Well, yes,
Cost.
but what I'm saying
trying
is,
to design
as we
with
drive,
all the variables and all the unknowns and all the maybe and what ifs, all the contingencies, and that's why people were saying, expressing concern for trying to design out that far.
But-
I'm not saying it's right or wrong. I'm
Right.
just saying that's
But it's funny,
where the concern came up.
it's funny you say that because we did look at that and it came back as a negligible number.
Exactly.
So that wasn't as big a factor as we thought it was.
When we ran the calculation,
Yeah.
it didn't look like it was that big of a number. So
Right.
if you take this equipment and you apply, I'm just gonna call it equipment for lack of a better
Right,
description. If you take the design that Giorgio's provided with equipment it appears, and we're not supposed to be discussing this part of it. We're supposed to be discussing the criteria of how we're evaluating. So, because now I'm starting to talk about the merits of one system versus the other. That's not the appropriate, that's not part of the conversation. What we're supposed to be talking about is how we're gonna evaluate this. I'm just trying to say, how do we put it into mathematical information that's statistically based, so it's not subjective? And if,
Well,
Stephen,
but-
we can't do
We-
that.
we will try.
If we can't do that, that's understandable.
We
will
will
try.
eliminate as much as possible.
Eliminate
Yeah,
as much.
no, we will try,
Okay,
but
so if we're getting an agreement,
Yeah.
consensus of this group, that that's what we're gonna try to do, I'm fine.
I think, just, I'll give you one possible example of what we might be able to do is if we were to do 2070 versus 2050, what would be the difference in sea level rise between 2070 and 2050? And what are those inches? Like, I mean, I'm being very basic, but that could be something how we could do
But
that.
the furthest we go at sea level rise, the less accurate our projections are probably gonna be.
Yes, I mean, guys, we're not putting this through a computer model.
I'm saying, if you're gonna go to
Yes,
2070,
but no, but we're not putting this through a computer model. We're not putting, but we're not putting this through a computer model. What we're going to do is we're gonna look at this, it's gonna be presented to us, and then we'll make the choice if we're willing to take that
So we're
risk.
not here all night discussing the merits of this, okay?
Yeah.
So
These are important now.
it's important, but all I'm requesting, Steve, is when, and I think the committee as well as our colleagues would like to try to take as much subjectivity out of the conversation as possible, okay? And I think if we can get consensus on that, and then, Mike, if there's other criteria that you wanna present,
Like,
Because I do
Bill,
think that-
let me finish real quick, Mike, sorry about that. A risk statement that is not numerically based can still be pretty objective,
okay,
right? And so we'll try to phrase it in a way that says, this is a risk. We may not know the exact number, but there is a risk that this may happen.
because I don't think it's gonna affect assurability based on which
Yeah.
one we decide to use.
No, we want to be as analytical as possible on each one of these elements. Those can then have different weight based on each person.
Do you have insurability up there? as
We
one of
do.
the Criteria?
Then what
But
insurance?
the next one will be environmental impacts. We've discussed this at length, water quality, landscaping, nature in the village.
Okay, so I think we have one, like, for example, effect, to the community.
Yeah.
Yeah, we do later.
So we'll just go through these if we can, just go through them real quick, and then we can discuss any of them specifically. Constructability, regulatory compliance. So this is how easy is it to construct? What are the hurdles that go through it? We know that both of them have different challenges. There's actually a phasing, feasibility, utility conflicts. So there's a number of easements, land acquisition, we've gone through a number of these. Cost. This one is
So
fairly
as
straightforward,
an
but we want to make
as
sure.
an example to that, so let's just say constructability, easement of constructability.
Mm-hmm.
Based on your understanding of these current two designs, which one is easier to construct when it comes to digging up the road? The effect on.
Yes, I
effect
mean,
on
there's
the
one that has a lot more
Yeah.
building of roads. It has bigger pipe, it has bigger trenching.
So the closest
Right.
relationship.
So
to
I can,
what-
yes,
The closest relationship to what the community has seen before when it comes to this type of work, civil works, was the sewer piping system that we put in about 12 or 15 years ago, where we had holes in the roads that were 12 feet by 20 feet deep and plates over streets for literally a couple of years, okay? So I don't.
That's what you're gonna see.
So, exactly, so people need to understand what that means. You're a construction guy, but Tom just expressed that he wasn't a construction guy, okay? And he's the customer that is going to see that plate in the middle of his road with a 70-inch pipe running down the street. That's a big deal.
How do you
okay?
put a number on it?
Yeah, how do you put a number on that? Because that's the.
Oh, yes, again, we recognize it.
Can't put a number.
Yeah, but you can recognize that, because you can say this is this, you can say constructability of this particular project over this particular time is going to be X amount of years on this street, and it's gonna take this amount of time versus this system, it's gonna take this amount of time. That's a way to put the numbers to it.
Yep.
Okay? So if that's the kind of data we're talking about, that makes sense.
And we're gonna try to get there.
construction schedule, construction
yeah.
phasing.
Because that's a big time commitment.
I think you hit it right on the nail there.
Yeah.
Oranges.
And also, on the flip side, the GIT's recommendation is there'll be 6 mechanical systems going into 6 unlucky locations in the village. And what is it gonna do to those specific roads?
Mike, I think you hit it
It's
right on
power.
there because you stated something very important. This is a financial programmatic issue that needs to be laid out in some GAN format or something with, we need to understand how this thing is gonna be laid out.
Well, then, good transition, we got cost.
So then we have cost.
Okay.
When we talk about cost, are we supposed to consider the $8.5 million, whatever, as some cost now with ACOM versus, or saying, okay, now whatever we spend with these people, we already have spent the money, so
I think
it's not
that's the
important.
sin of the past that we can't deal with.
We look at cost.
If you want to consider overall cost of each one of them, then you can consider that.
That just clouds the issue at this point. I don't think we should, even though it's a lot of money, we are where we are. And now the question is, which path are we taking forward? And I think we should just look
I
at
agree
that.
with Nancy.
Generally speaking, it's cost moving forward.
I mean, we're talking about cost, that's all.
Yeah.
Because you look one
But
versus the other.
so it's life cycle cost, it's financing cost, it's cost structure,
But it,
cost per resident.
Well, when you talk about life cycle, are you talking about the life cycle of the equipment, or the life cycle, the time horizon that we expect each program to be effective?
Well, that's a good point, because there is a component of that, and we'll discuss that, but what is the life cycle of a pump?
Or generator?
15 years, 20 years? So you're gonna have
How
to
long?
replace those, 15 years?
And how, if it's used, what, 5 times a year? How long is it last, 10 times a year?
No, it'll be used more.
I mean, they really last a lot more.
Second generator though, is gonna be run once a week.
Sorry?
Second generator is gonna be run once a week.
And if a pump was, and Councilman, if a pump was,
okay, I think.
in.
Yeah, we've got the components up there, so
Doesn't matter.
O&M, where'd it go?
Oh, sorry,
O&M replacement, energy, so that is a time component of life cycle.
which is different than the next one, which we also have operation and maintenance, which also has O&M cost impacts, but it also has staff capacity, it has design life, which we're discussing, maintaining, storing equipment. So you can look at it analytically from both sides.
And we purposely,
And
we purposely divided cost and funding apart, because cost is, how much does it cost? And funding is where we're gonna get the money from. And those are, although it sounds the same, it is 2 very different things.
yeah,
Because, there's a whole cost funding structure you have to put in place in order to pay for those costs. And then not only how would you pay for it in the moment, in most cases, this is going to be a loan, a grant, actually a loan or a bond, and therefore we'll have to pay for it over time. And so that's also important as well.
That's a big discussion because there's a whole other stuff that
Yeah,
plays a
but
role.
I think we gotta be careful with this conversation about whether we're gonna use stormwater utility funding, or what's the special grant program that we currently have?
Clean water.
SRF?
We have the SRF program, but we haven't applied for the SRF program for the.
it's still applicable. We can apply for an SRF loan with
For either one.
alternate.
So we can't, so what I'm trying to be careful with is we can't say, okay, well, we have SRF funding for this particular project, but we don't have SRF funding for that particular project because we haven't applied for it, so we don't really know, so it's not really.
It's a
not really
component.
It's not really fair to compare the two in that fashion.
No, I
But
would
you can't-
disagree, though. It is fair because we have funding in place to do it.
It still has
The
to
other
be
one
part
is,
of the
we're not
analysis.
guaranteed we're gonna get the other one, but we're sure as heck gonna try, right? So I think those are the sort of things, we have to acknowledge those.
Okay, but do we clearly have that funding? Do we have it locked
Yes.
and loaded? Do we have
Yes.
an agreement in principle, not just
Yes.
we
I
believe?
mean,
Yes.
you'll still have to vote on signing the agreement, but it's approved.
Okay.
But that's, what I'm saying is it'll be part of the analysis, but that doesn't mean that we can't get the same. or,
Oh,
the same
we're not
loan.
gonna work our butts off to
Right.
get it. I mean,
Right.
that's, yeah.
Tom, you have a question?
Yeah. Nobody's here. Hey, Brent, Tom. I think.
You guys dress the same?
Your instinct, he looks better than me. Mike, your instinct is right, because the nonsense out in the community is about, this guy's never met a dollar he didn't want to spend. this guy, Ed's never seen a project he didn't want to kill, right?
Yes.
I love
You
this
got it.
vendor, I help this vendor, I
Yes.
want my resume to look good. There's all this nonsense. So to the extent that you can have objective, it's gonna cost, $18 per unit of benefit, and this one's gonna cost $17, so let's go with the seven, that's great. But the issue is I didn't see a single criteria here that I disagreed with. Everything on that list was great, but it was 35 items. No one out there has the capacity to think about that. So I go back to what I said before. I complain all the time to you guys about how bad Curtis Wood is. You know what? In truth, has it really impacted my quality of life? Barely. Okay? So with undergrounding.
Don't ask me that question.
Okay,
Don't ask me
Joe.
that question.
But I don't want to just hear that your house sometimes floods. I want to know how. So remember, I said this a while ago. With undergrounding and stormwater, let's talk about stormwater. We have dry days where everything is great. We have plenty of days where it's a slight inconvenience. And then we have horrible days where it's flooded. You can't do anything. There's BMWs lined up on Westwood with their lights that are stalled out in the flood. Okay, so the question is, how often do we have horrible days? And if we do this, how much better is that going to be? So translate all of these 35 criteria into, guys, Joe's house is in ground zero for flooding. That means 15 days a year, his life is ruined by the flooding. And if we do this, it'll be 14 days. Everyone wants you to vote no. If we do this, it's going to be 1 day. Everybody's going to want you to vote yes, right? That's how simple you have to make it. How often are we terribly inconvenienced by the stormwater? And how much are you going to remediate that at what cost? Undergrounding. How often, not a flicker, right? Shut up. Your modem reset, you had a flicker and we're complaining. Stop complaining. Oh, but your power was out for 6 hours? That's a really big deal. Undergrounding. How, and I know you keep beating up FPL and they don't have a good answer, but how often do we suffer material inconvenience because of blackouts? And if we make this massive investment, how much will that be remediated? If we have, and Ed, you keep going to this, if we have 15 blackouts a year and we spend 50 million and we have 14 blackouts a year, you've all failed. But on the other hand, if we have 15 and you take it down to 1, you've all succeeded. That's how basic I think we want to hear it. Is it really, Joe? Is it really? I know your house is at ground zero.
Sit down and show you.
No, but is it really going to get better? Show us. Yes, Joe's house is underwater most of the time, and now it won't be. 30. I know you guys have to do all this work, but that's what we want to hear. How much?
Yeah,
is
but
it gonna
I
be?
think what you're mentioning about flaws or stuff that is being said out there, I think one of the things that is not being said out there, we're analyzing two components, two infrastructure components from the same perspective, and that's not it. What if I told you it's not really so much about the quantity, but it's about the speculation of municipalities and what they're doing to protect themselves, including coastal communities, particularly coastal communities, with FEMA, with moods ratings, correct, Mr. Manager? I mean, and those components play a role in our financial condition. We are an exposed coastal barrier community in the midst of hurricanes, and it's not a question of how, where, it's a question of when. And we are technically, according to maybe Wall Street or other insurability elements out there, we're exposed. We're not doing our due diligence. Well, is it true or is it not? We are exposed. So
I understand what you just said, and you're going to.
Okay, fair enough.
You got to articulate it.
I have.
Okay,
It's going to be
the potential of flooding reduce our credit rating.
yes.
But we already approved undergrounding, we're not talking about that.
No.
No. We're talking about
Say
stormwater.
electric.
Stormwater. Okay, let's
Right,
stop
we're
talking about
stormwater.
But I get what you're saying, Tom, but I think you understand that very clearly. The risk of flooding reduces our credit rating.
That's probably.
Yeah.
Great.
Would-
And if you can tell me that's going to cost us.
It will. It'll increase what you pay on all your bonds.
How much, and how much much is this? If the bonds are gonna go up by 90 million and this is gonna cost 80, do this. If it's the other way, don't do this, right? We have to have some kind of actually discernible ROI
But
calculation.
we also don't have kids driving to school with their golf carts underwater and walking out of class when there's a big rainstorm and having to wear gummy boots to class.
And how often does it happen?
That happens more often than you think, Tom. Okay? And
No, I'm not saying it doesn't happen. I'm saying, please tell us how often
what,
that
you mean,
happens.
whether it's 20 times or 15 times or
We're
10?
dealing
Well,
with
I live
Mother
on Curtis
Nature.
Wood, and it's 5 times a year, and you know, and an hour later.
It's about 5 to 10.
But
Once, so it was once a year,
anyway,
one time.
But these are the questions that people decide to vote on what you're talking about.
Right.
It's not how we're making decision. We're making decisions on these various criteria, what's better, and then putting it down to what you're talking about. Do I want to pay $50 a month, or I want to pay $200 a month, or I just have the way it is? That's what you're really saying. But I don't think that's what we're doing. We're going to look at these various things and look at the total cost and the benefits and come to a decision.
right.
That's all.
And
And
that's
then,
what we-
I understand what you're
elected to do.
saying, then the community can decide, hey, this is ridiculous, I don't wanna spend, whether it's 30 million or 100 million, it's too much. Because I don't believe, like you said, that it inconveniences my lifestyle. But when people don't look at 30 million or 50 million, they look at $20 a month or $50 a month, whatever the cost is, on a monthly basis, and for most people, it's gonna be insignificant.
I'll shut up now. I just want to say, I know you're doing the right work, but articulate it to the community in a way they can understand. I believe you, Joe, how bad it is, but let's say how bad it is. Brett just said it's 1 day a year. Well, Joe, it's 15 days or 1 day. I know you're not saying the same thing, but
But it's different.
you need to
But it's,
Joe
understand.
lives in a different area.
Tom, it's a different neighborhood.
Well, also schools have to happen at the exact time that people leave. I mean, if it happened earlier, it would have been already gone by the time the kids leave, so
I mean,
it's a difference in area.
It's different in different neighborhoods. I mean, it's terrible in his neighborhood, and
That's why he's on council.
yeah.
But Tom, we're so happy you brought that up that we
Stop
actually
the
put it right here,
Okay.
right in the middle, perceived value and cost benefits. So
But this is
there you
probably
have
the one that gives me the most heartache because it's the hardest to
it.
even
Because it is
analyze.
subjective in
Right.
many cases, because a lot of that numbers, although it sounds, you can describe it and have a conversation about it, it's really hard to
And
capture.
each person's gonna have a different impact. But at the same time, we know this is one of the most important criteria when it comes to why we're doing this in the first place.
But at the end
If
of the
it-
day,
if it
all
wasn't,
of this
we wouldn't
is-
be
all
here.
of this is going to be public. We're
True.
going to be discussing it ad nauseum, and the public is going to be able to come to the meetings and weigh in and figure it out how, and that's the way the decisions are.
But there's one more thing. With all this criteria, sounds great. We just said this is a level of service we're trying to attain. ACAM came and said, hey, here's how I'm going to give you this level of service. Here's my pumps, here's my equipment, here's this and that. George is going to come and he said, here's the level of service. I'm going to give this and that and everything else. If they're both going to meet that same level of service, how
No.
important,
No,
you're
they're gonna
shaking
be
your head.
their own.
How
designated.
important are all these other criteria? That's what you also have to ask.
But they're not going to meet the same level of.
So the point is, look at the difference in level
Right.
services, not the same,
Right.
Right.
and saying, how much is that difference in level service worth? And
Exactly.
then we make it.
And those are the-
calculate
that's a-
decision.
that's a
By the
fair
way,
statement.
that's the real conversation, because we know that change in level of service is exponentially more expensive, okay? Because we went back to that criteria, and we said, okay, lower the volume of water, and we found out that the water volume changed dramatically. The only thing that we could really value engineer in the ACOM system was to go back and reduce the amount of pumps in the pump station. Okay, we
We
weren't
went
gonna go
down to
back and.
77 CFS.
Right.
Giorgio's has a thing at 90 CFS. So he has basically another 20% more than the ACOM capacity.
Okay,
So, in its most simple form, we'll go back to this
okay,
one more.
1 through 5.
We would have something like this, and we can discuss today, we can discuss later, which one of these 8 or so, 9 maybe, are the highest weight, and then we go through and evaluate. This is basically what we will present, backed up by the information of all those criteria in the end. To describe how we got to a 4, 3, 2, 1, whatever it is.
Okay, so you look at environmental impacts. I guess that's dumping the water in the bay versus dumping the water into the
It's a
ground.
big portion of it.
Sorry?
That's a big portion of it, yes.
So as a result, how would, you put a weight on that, but for a lot of people, that makes it
Some people-
no-brainer no matter
Some
what.
people make that a very high weight, other people
Well,
don't have
but
any
I'm
weight at
just
all.
saying, for a lot of people, I'm not saying for everybody, but I'm just saying, these are various criteria, how you actually put a thing on that.
That's our job.
That's the subjective.
But that's how we
Part
work
of
it
the
out
council.
as a collective, saying what's most important to us.
I'm gonna give you all the analytical data. I'm gonna give you, here's all the different criteria.
No, I'm just saying,
Why will not?
when you
No.
tell people,
So,
you're putting
that
30
to you
words
is
a
the highest
day,
criteria.
it might be thinking.
If it's most of it, yeah, well, I want to understand, yes, if it's most of it.
I
then what
swim
is
in
the
it every
degree
week,
of- What is
so
it?
I
Okay,
understand.
okay, put 5 or 0, whichever is the
That's
one that
all.
goes, no, I don't.
They say, oh, you pay more.
That's
not
why
to.
I agree with the wells,
So,
for that
you know, so
perspective.
It's,
what the average person.
But there's also, I mean, this.
You know, I'm not sure we can
spreadsheet,
do it
and
all.
If we say, let's just say we, right now, say it's a 1 out of 5,
You know,
it's 1. Now, if we end up saying making it a 4, obviously those numbers change.
then we look at technical performance, your first criteria.
Mhm.
We have to assume that, number one, AECOM has analyzed this, their pump system, the size of the pipes, the location of the manholes, and all the other things. We have to assume Georgia has done the same thing with a different system. So how can we determine which has better technical performance?
Okay, can I just say a couple of things on that?
you go through all these different
Can I
samples,
finish?
and maybe I missed
It's a
some.
reasonable
And
question.
maybe there's some,
Yeah,
and
right.
that's where I asked,
Sorry, I thought you
and that's why we share this. If there's something that you think should be on here or shouldn't be on
I'm
here,
just saying, how
there's
can-
probably some that are a little
I'm sitting here
repetitive.
I'm sitting here too, saying, okay, how do you change the technical performance? Well, the only thing that Giorgio does not have control over, okay, that he can't change, is the size of the existing pipe system.
But he can,
Well,
he can upgrade
he
it,
can recommend
and that's
ripping it
part
all
of
out.
his design, yes.
But he could.
If it's
recommend-
critical.
Mike, let me finish, please. He could recommend ripping it all out, okay, but the criteria that we asked him to use was use the existing system.
No, we didn't do that. We told him to build to a certain level of service. He's choosing to use it.
Okay.
We asked him to
But we
take that
did-
into consideration.
But we didn't, but
We thought it was a great idea.
we thought it was a great idea because it was reducing cost, okay? So we know if we would take all those pipes out and put new pipes in, the technical merit of that system might be slightly increased.
Maybe.
Maybe, okay? But so.
You
how-
would think so.
You would think so, but how do you put a numerical value to that and say, this is better than that? Because to me, they're both.
We're not saying it's better. We're asking the question, is it meeting the level of service we asked it to meet?
Well, the answer to that is yes, because it's
Well,
the design criteria.
he still owes us a lot more work on this. We're not there yet with
Okay. but
GIT.
Assuming that,
Um,
that he signs and seals those drawings and says, I put my name behind this, and the guy at AECOM says, I put my name behind this, they're two professional engineers. Who's to argue that they're better?
That we may not argue,
Okay,
right?
then,
But-
then why have the question?
Because I think
You
that's
still
the
have to
whole
have a
basis.
standard.
You have to ask the question, is this gonna work? I mean, you can't not evaluate something without asking the question, is this gonna work?
I mean, if I'm gonna.
That's
if-
that's 100% my job, is to look at.
Say, will it work or not?
I had a team of engineers review his, we worked together, we collaborated.
I understand.
I mean, I think it's ultimately gonna be more beneficial. That's what we're doing.
So, but Mike, what I'm driving at is that it's a little inappropriate to do this in front of Giorgio, but to sit here and say, okay, he's an A plus and this guy's an A minus, this guy's an 8 or a 9. I don't mean, how do you, when you Black and Beach go out there and you say Black and Beach versus another engineering firm? I mean, how do you evaluate those two firms based on what? Outside of their professional merits?
Well, neither of these are personal evaluations, so these are gonna be based on the design and based on the systems. Now, they're designing those systems, but they're also picking it from different limitations, being asked to do different things.
And remember,
So
Black and
it's
Beach in this
not
case
a
is not
direct
Black and
comparison
Beach,
of-
this is Black and Beach as the owner's rep.
No,
So
I
this is the
understand.
village
I
doing this
understand.
evaluation
But it's
through our
still
owner's rep.
subjective, for example, when you get to system reliability and redundancy. The ACON system has redundancy every which way, right? Generators and everything.
Actually, there's no proof of concept on the AECOM system anymore. There's a proof of concept on his system, on
But-
Giorgio's system. They neither have been built before.
That's not true.
Oh, come on.
AECOM went to full design. AECOM went to full design though. I mean,
Okay,
so
but they went
But
to full,
there's
they
no,
went
but
to.
I'm just saying, there's no proof that if we have generators at every corner, that's gonna be reliable.
But
That doesn't really get us to where, that's we can
I guess my
realistically evaluate,
my,
that's
I
the
guess my
problem.
conversation is based on gradient, okay? I don't believe that this system has been put in an area with this low a gradient differential, okay?
You're putting it in all
Which
over
system?
Miami
The,
Beach.
the system that AECOM has designed, has it been put in a?
Yeah, they do.
Yeah.
But then when they had
Sunsets
but they
1 and
barred
2,
the
go
pipes
look
enough
at.
Okay,
to take care of that. That was
Go
the
look at
whole
Sunset.
idea, I understood. To
Right.
get the flow is to make a much larger pipe.
so they kept using the bigger and bigger pipe?
Yeah.
Okay, versus going to a forced main system?
Yeah.
Okay.
Well, I would not necessarily agree with that.
You wouldn't?
Pipes are not used for storage, pipes are used to transport flow, and they're used to transport the peak flows. That's a nice thing to have, but they're not necessarily there for that. Islands, you can look at Palm and Hibiscus, you can look at Sunsets 1 and 2, you can look at Normandy, you can do Biscayne Point, North
they're all
Shore.
using this
They're all
stuff.
there. They're all large pump station, large pipes, $2.6 billion investment Miami Beach has done on their storm road, 2.6 billion, yeah. So, and it's still growing. So, it's a significant, but that's Miami Beach and that's us. And I think what this brings up is it brings up a solution for a smaller community. Miami Beach is a very dense community. It's, the county too, they have a widespread tax base. They can afford these things. We have to go with things that we can wrap our heads around a little bit more. So I'm kind of inclined more towards a treatment train or a disposal train. We can talk about that later. I did want to touch base on a couple of things here. I don't think I agree.
Where are you, Fernando?
I'm sorry, yeah, I agree with Councilmember Bracken. I think I am not comfortable with weighting the criteria based on this. I think it induces politics into engineering, and I don't want to do that because it'll bring subjectivity. I think your role, whoever, Black and Beach, I don't think it's him or AECOM, is to come up with a sound, objective comparison between the benefits of this project. You can look at logistics, you can look at construction, you can look at, it has to be measured one by one. We, as council, are not the ones who are gonna make a decision to go with A or B. We're gonna come in with a recommendation based on something objective that you guys generate for us.
It will be my recommendation.
This is not.
It will
what
be
we
my
want to
recommendation
do.
to the council.
I don't wanna do this. I
No,
don't know
no,
about you,
it
but
will
I
be
don't.
our recommendation to the council.
But you
Okay.
want.
But you want it.
no evaluation?
I do, I'm asking the professionals, the professional engineers to compare both systems from the standpoint of all those parameters that are listed out there, whether by points, whether by,
Okay, so Fernando, the
whatever it
question,
is.
do you agree with the criteria?
Well, no, there's some things, we got environmental risk and climate resiliency, then we have environmental impacts, it's the same thing.
No,
Yeah,
not the way we're defining it.
Well, but you're not explaining it then. Constructability and regulatory compliance, that is a very complex constructability. It's a very complex subject because it includes logistics, it includes mobilization, it includes stuff that we don't know, potential change orders. We don't know that. We can't tell you anything on that. Cost, what are we talking
So
about?
you say-
Okay, you're saying
We, the council, or
we, the council versus the professionals to
Right,
come
spell
up
it
with-
out, tell
No,
us.
no, no, so Fernando, I think we're confusing ourselves here. They're asking us to approve that list.
No, I don't approve it.
For
Not
them,
for us to
for
do
them
it,
to
for them to do it.
reevaluate.
Yeah, but I don't approve it in the way it's presented.
It's for us to do it.
Okay,
This is for us, not them.
No, it's
No,
for
no.
them.
No,
that's for them.
Okay, if
them.
it's for them to do it, I still think this
No.
needs work.
But
I'm sorry.
we want your all's feedback, though.
We want,
Yeah.
they're asking us, do we agree to these criteria items? And they're going to provide the data. Okay,
But look, we
I
can't,
think
we
you
can't,
guys- I'm not sure if this is, to be honest with you, okay, so we don't approve it, that's fine. But you guys are gonna go with this? This
Well,
needs
what do
to
you
be-
want? What do you want?
Okay,
What do you want?
okay, for example, cost, are we talking construction cost, or are we talking opinion of cost? What are we talking about?
well, it's,
Well, at this
well,
point,
it's the
George,
it's the
both
costs that we
continue to
have.
cost.
It's the costs that we have.
Yeah. Construction cost is that when the contractor
Well,
says, here's your
it's actually-
project.
But,
we don't have-
Fernando, we don't know what that's gonna be. We're gonna go with the costs that we have.
So they, then say engineering opinion of cost.
Yeah,
You know, give us,
Yeah, but it does have to be specified that that's what it is.
right,
And not,
right.
not
We will, we
construction.
will.
Cost
It's-
sounds like,
You have.
But, because it sets, Steve, inadvertently, we're setting the wrong impression. This gentleman, this nice gentleman here would say, set the right message. This doesn't send the right message because you guys are gonna give us an engineering cut, and then the community's gonna run with it, and that's not the
But
construction
look, but,
cost.
you know, we can't, you know, and I appreciate what you're saying.
Opposite of what Mike's been saying all night. He
but
wants
you-
quantifiable stuff so that
You can't
it's-
have it.
But Fernando, you can also say, geez, we, you know, you've done construction before. And you gotta go with what your engineers tell you because, and then you, if you choose to put a contingency on there, but you can't sit here and say, gosh, this guy made change orders to death. Well, then we'll never know the cost. And then we're just hamstrung and we never make a
This
decision.
is the reason why I've been saying over and over again that this whole thing, in my opinion, has been a complete exercise in futility. Because we're trying to, the cost has been the issue why we engage in the second design. Of course. Because we wanted to get an opinion of cost. We never got the construction cost. You give this to a contractor to build out there, it's not gonna be 90 million. I assure you it's gonna be far more than that. I hate to tell you that.
No, you don't,
Experience has told me that.
you don't need
West
it.
Avenue went from
But
46 million to
you're
120
assuming that though, Fernando, but
you gotta go through a process.
we gotta have a number to evaluate.
But say opinion of cost.
We will do that, that's fine. If you want us to put opinion to cost, we'll do that.
If any other changes and recommendations,
You guys,
welcome feedback.
this is what.
But they want,
Are we gonna have, is there gonna be some kind of narrative other than just the points?
Yeah.
We have to send it.
yes.
Because I think that's more
Yes.
important than the
No,
points.
although the analytical analysis of here is
Environmental impacts.
the pros, here's the cons, here's the benefits,
In the bay.
For me,
here's
that's
just an
more important
explanation,
than the
here's the
points.
impact, here's a quantitative number, when we can put quantitative numbers at it. And then
Doesn't really
all
matter.
of those items that we've analyzed will be translated into
Operation maintenance, that's okay.
lack of a simple.
I think cost is.
So gentlemen, they're asking us to give us some, if you don't like some of the things on the list, strike it out, okay? And strike it out and say that's not the ones you wanna include.
I just want a narrative because the points to me, no.
I don't want technical performance. I don't want constructability and regulatory compliance, because they have to assume both programs are permittable and
Right.
conform with the regulations. So I have to assume that doesn't make any sense to me.
And
Environmental impacts, yes, that makes a big deal, so I have that in there. Cost, yes. Funding, no, because you can only say you have funding for one program, you haven't seen me get funding for the other program. You
Yeah,
can
but
say
you know
something-
what, but Ed, you know, honestly, the fact that we have funding for the ACOM program may make it more desirable to some people. That doesn't mean
No,
that
no,
we're not gonna get
But
funding
you don't know if
for,
you can't
for
get the
the,
same funding for the other program.
but that has to be explained.
Well, fine, explain, but I'm just saying, that should be criteria to decide which program you're gonna take at this point in time. Now, once you do something and you find out you can't get it, that's something completely different.
I think constructability when it comes to how much time it's gonna take and how much impact in the community it's gonna be is a significant cost that we have to, operating cost or life cost, whatever you wanna call it.
So I think cost is fine, operation and maintenance is fine, community impact and public acceptance is fine, coordination and supporting efforts, all that's
So
fine,
what do you,
in my opinion.
Ed, what do you think about constructability when it comes to how long it's gonna take?
I mean, we just had a 20-minute
That's community
conversation
impact.
about how much we're gonna
But
open
how
up
is
roads
that different
and how
from
it's gonna
community
impact.
impact? How's
I said that's community
constructability
impact.
different
Well,
than
that's community
community
Yeah,
impact?
of course.
Okay, I don't- okay, I don't-
Constructability
It's gonna
is how
take
the
time.
project is going to be built.
So I think
and
we're
then
talking over each other.
They're not,
So
they're
that's part of the
associated, but
problem.
that is.
I think we're getting run out of bandwidth.
Yeah, I think.
Yeah, you good?
Why
so I would
don't
ask-
you work it with our staff?
Yeah, we leave it to your good judgment.
Oh,
So
Yes.
why don't you all provide feedback to me?
Yeah, okay.
Then Mike and I will sit down
And come
And-
up with
and we,
criteria.
we'll see where this is.
Guys, it's a good effort. I'm not saying it's a bad effort. It's just that we're confusing issues. And I want to make sure that we're not sending the wrong message to the public. At cost, it needs to be stated very clearly. This is an engineering opinion of cost. Because people
We'll
will
do that,
run
Fernando.
with that.
Right,
And
they
then
will.
tell the public that this
They
is
will.
$100 million is going to cost us. And that's not true. as a simply you guys grab it.
But Fran, you can't say that's not true
No,
because,
it's not, because then the contractor's gonna get different pipe prices.
but I know,
He's gonna get different equipment.
but Fernando,
He's
if,
gonna
if,
get
but
different
Fernando, if
design.
every time we get an engineer's
It's gonna
opinion,
lowball you, you never know.
but Fernando, if every time you say you cannot
build anything if
respect an engineer's costs, then we would build nothing. Because everyone would say, okay, so it's $10, so it's really gonna be 15. You don't know that, nobody knows that, we don't know.
We're actually arguing about something that, in my opinion, is so important for the public to know exactly that this is not a construction cost, this is an engineer's opinion of what the cost would be if it went in a perfect world in construction.
Okay,
We've got it, it's an estimated cost, and that's all we've got, so we can't predict what's gonna happen in the future.
That's all we can do.
Best guess.
Best guess.
It's a little more gas, but yes.
It's not a best guess.
You're gonna just do this for fun now. All right,
We'll leave you
calling the
in
meeting
here.
to
We're
close.
Anybody else?
Yes.
All right.
Anybody else? Wait, Brett
Brett
has
is
something.
2.0.
Brett
We're
has
out of
something.
order, next.
Sorry, Brett Moss, 152 West Master Drive. No, just listening to this, it worries me of how the public might take this. And I think the criteria is good to look at, but I think you guys are also right that there's only really two quantifiable things that you're going to look at. One is your level of service, and two is the cost. But all this stuff is important, but I don't understand what the reasoning of weighting everything and putting a quantitative number next to everything. Why not just look at the two actual quantitative stuff and say, this is what this one does, this is what this one does. And you guys just decide on which one is the best one, but coming up with
So
numbers
let me
as
give you an
subjective.
example. If some equipment only were to last 15 years and the other one lasts 50, wouldn't that be?
You should put that on there and say, this is the cost, and this is
That's all
15.
we're saying with this kind of reasoning.
That's why I'm saying.
But the thing is, the data you put in, the results are only going to be as good as the data you put in, and some of the subjective stuff, you're making up numbers, and you're putting certain weights in there, and then you're going to look at it, and, well, we can change this and change it, but then you're not really getting real numbers anymore. So maybe you only quantify the real quantifiable numbers. Everything else you just list like, here are your benefits and these are your cons for this one, and the same with the other.
Brett, I'm good with that. All I was trying to do is trying to remove as much subjectivity as possible. To make it as quantifiable as possible.
What you're
Right,
saying makes
but
sense.
you have to have in everything that you
do.
do
There's
is
a
your
risk.
pluses and your minuses.
Absolutely.
Okay, and that's what I see as some of this is.
Yeah,
Okay,
that's
this is
exactly
a
what-
plus. This is a negative.
I don't disagree.
And look, it may not come across looking like this when presented. We just tried to, I mean, look, we could have thrown all these in different places, but we wanted to categorize it to have a logical conversation with you. Because,
We're saying this, but I'd love to help you. Coming up with an idea maybe that can help. And just something that we can all make a decision comfortable.
Good.
As a council member, maybe work with you guys and whatever. I mean, I want something objective.
Yes.
Something,
Please,
you know,
feel free, man.
Yeah, let me work with you.
Are we done?
Seriously.
Absolutely.
We're done.
Good. Thank you.